Yo, what's up, guys? Today I'm back with another banger video, and today we're doing October-November 2025, paper 11. So let's just get into it. I'm just going to put my name down over here on the paper. For those of you who don't know me, my name is Amin, so I'm just going to put it down over here. Okay, first question. Find the set of values of the constant k for which the quadratic equation something 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 equals to 0 has two distinct real roots. Now what this basically means is they're asking you to find the value for this constant k, and as you can see, this equation consists of the constant k. Uh, and then they give you a condition, that is that you have two distinct real roots. So what you have to do is you basically have to connect all of these pieces and basically find out those set of values. You have to find the set of values of k based on all of these pieces. Now, how do you use all of these pieces? So the last part of this statement has two distinct real roots. Basically tells you that this is b squared minus 4ac, or the discriminant of the equation, of this quadratic equation, is greater than 0, or in other words, is positive. Now, the discriminant of a quadratic equation is basically this thing, b squared minus 4ac of the quadratic equation, and this part has to be positive. That's what it means to have two distinct real roots. This discriminant basically comes from the quadratic formula, which is minus b plus minus under root b squared minus 4ac over 2a. So it's basically this part inside your square root. Okay, so we know that this discriminant has to be positive. We know that we have a quadratic equation, and then the quadratic equation has a constant k. So we have to find the values of k. So this equation doesn't have k. It's b squared minus 4ac. We're supposed to find for k. So how do we do that? Well, first of all, you basically find what your a is in this equation. And remember, a is the coefficient of the x squared term. Over here, the coefficient is going to be 3k, and your b is then going to be the coefficient of the x term. So the coefficient of the x term is k plus 8, and then your c term is basically positive 3. So these are your a, b, and c terms. Now you basically put all of these three terms in here, and that's how you're going to get k in this discriminant. So b squared is going to be k plus 8 squared, and then you're going to have minus 4 times a, which is 4 times 3k, and you're going to have that c term, which is 3. Now let's simplify all of this, and remember, this has to be greater than 0. That's what two distinct real roots means, is that your discriminant value is going to be greater than 0. So if I solve this out, first of all, I can expand this part, k plus 8 squared, and this is basically the identity a plus b squared. You can expand it out using that. So the identity that you get is a squared, so it's going to be k squared plus 2ab. So 2 times k times 8, that's going to be 16k. 2 times 8 is 16, 16 times k is 16k, and lastly you have plus b squared. The b term is 8, 8 squared is 64, and then you're going to have, you can simplify this remaining part, so 3 times 3 is 9, 9 times 4 is 36, so you're going to get negative 36k. All of this has to be greater than 0. Okay, now you have k squared. Let's subtract this term from this term, so we got minus 36 plus 16. That is going to be negative 20k plus 64. Okay, so if you look at this part, this is a quadratic equation. It's a quadratic equation not in terms of x, but rather in terms of k. So this essentially, what you have over here is a quadratic inequality. It's a quadratic inequality. And what you can sort of do is you can solve it by using this method. So let's say you have some y, okay? And y is equal to k squared minus 20k plus 64. So when you say that this k squared k squared minus 20 plus 64 is greater than 0, you're essentially saying that y is greater than 0, because you say that this quadratic equation is equal to y. And so what you're finding out is you're basically finding out what are the y values for which this, for what y values is it greater than 0. And what do I mean by that? So I said this was a quadratic inequality, right? Which means this is a quadratic equation, which means you can make a quadratic graph out of it. So how do I make a graph out of it? Well, you find the two roots. So you find the roots of this thing, and the way you can do that is you can either use the quadratic formula, you can use completing the square, whatever you want to use. I'm going to go with the quadratic formula. So it's going to be minus b, so minus 20 plus minus b squared, which is negative 20 squared, minus 4 times a. Over here, the a is 1 because k squared has a coefficient of 1, times c, which is 64, over 2a, over 2a. A is 1. So I can put this in my calculator, solve all of this out. So minus 20 is going to be 20 plus under root minus 20 squared minus 4 times a is 1, so I don't have to write it. C is 64, and I divide all of this by 2 times 1, that's 2. So I get 16, which means one of the values for k is 16, and then the other value for k is, if I change this to a negative, I can find that value as well. So that is 4. So k is 16 and 4. Now, what are these k16 and k4 values? These are the roots. So this is the root. These are the root values. Okay, this was a quadratic equation. I basically solved it using a quadratic formula, which means I found the roots of the equation. What are the roots of the equation? So why did I even find this? Remember, I was trying to plot out the graph. Why am I trying to plot out the graph? All of this is going to make sense in just 1 second. So this is my quadratic graph. This is my y-axis. This is my k-axis. Remember, I'm not solving for x. I'm trying to solve for this quadratic inequality, and it has k terms, not x terms. Okay, so I just found out two roots. The two roots are positive 16, and positive 4. That's going to be somewhere over here. And is this an upward-facing parabola, or is this a downward-facing parabola? Well, the sign over here of this k-squared term is a positive sign. That means this is a happy face. Positive means a happy face. This means this is an upward opening parabola, something like this. Something like this. So when I put this entire thing, this entire equation equal to y, and then if this entire thing is greater than 0, that means y it has to be greater than 0. Okay, because they're both equal to each other. So if one thing is greater than 0, that means the other thing is greater than 0. And so basically over here, what I'm really trying to find is I'm trying to find what are the regions where this y value is greater than 0. And so there are two regions. There's this region, and there's this region. So you're always trying to find out the roots when you're trying to plot out this quadratic graph or this parabola. Why? Because those roots, either the answer is going to be above those roots or it's going to be below those roots. If it's y less than 0, then it would have been this part, but in this case, since it's y greater than 0, it's the above part. So what are the values of k for which this y is equal, for which this y is greater than 0, for which this y is positive? Well, those are basically k is smaller than 4, and k is greater than 16. So this right here is your answer. Now going back, what you had to do was you basically had to combine these three pieces of information. First one was you have distinct real roots. That means the discriminant of the original quadratic equation has to be greater than 0, or it has to be positive. Then you write down the discriminant, and instead of b, a, and c, you put in the values for those variables. Then you basically solve out this inequality, and you put it equal to y. And then you make a graph for it, and then basically you're trying to find out all of those y values for that graph which are greater than 0. That's essentially how you do this problem. And so we came to this conclusion that there are two regions where y is positive. One is for all of the values of k that are smaller than 4, and the other where k is greater than 16. So over here, if you look, this is k equals 3, this is k equals 2, this is k equals 17, this is k equals 18, and they're all corresponding to values over here for y that are basically greater than 0. Okay, if for example, if you choose a value over here, let's say k equals 7, then it corresponds to a value over here, and this is in the negative region of y. So this is where y would be less than 0. So that's why we chose k is smaller than 4 and k is greater than 16, because in those regions, y is greater than 0. Okay, so now we have a progression problem, and it's basically a geometric progression problem. Says a geometric progression has first term a and a common ratio cosine theta. So this thing is basically your a term. A term is basically given to you as your a term, and your common ratio r is basically given to you as cosine theta, and then you're given a range for the possible values of theta. So theta can be from 0 all the way to 90 degrees. 90 degrees is basically pi by 2 radians. So the next part says it is given that the second term is 8 and the fifth term is 1 by 8. What does that mean? So second term of a a geometric progression. How do you find that out? So it's going to be AR n minus 1, where n is the number of term you're talking about. Since you're talking about the second term, this is going to be 2. 2 minus 1 is going to be 1. So AR, the second term, is equal to what? It's equal to 8. And similarly, the fifth term is going to be AR n minus 1. What's n going to be? Since you're talking about the fifth term, it's going to be 5. 5 minus 1 is going to be 4. So AR raised to the power 4 is going to be equal to 1 over 8. Okay, what we can do is we can basically, instead of r in both parts, we can write cosine of theta. So let's do that. So instead of AR, we're going to write cosine of theta. And since we're talking about the second term, we're talking about this guy over here. the second term, this doesn't have a power over it, so the cosine theta will not have a power over it. It will just be cosine theta. It's going to be equal to 8. Now remember, this is the second term, okay? And then we have an equation for the fifth term as well. So the fifth term equation is a cosine of theta is equal to 1 over 8. And what was the equation for the fifth term? It's this equation right over here. Since r has a power of 4 on top of it, this cosine theta will have a power of 4 on top of it. So right now, I haven't even solved the problem. I haven't done anything. All I'm doing is I'm just using the information the question gave me, and I'm just writing it out. This is so important. If you just read the statements and you just neglect them and you jump straight to finding the answer, you will have a really difficult time. So right now, we're just digesting the information. We're sort of breaking it down and what it means. This is really important when you're trying to solve problems. I cannot stress this enough, but it's extremely important. Now, I actually go and read the problem statement. It says, find the value of theta. Give your answers to 3 significant figures. So I have to find this value of theta. Now, if some of you didn't read the question statement properly, didn't digest the information I was given to you properly, they just jumped on to finding the value of theta, they would have a really difficult time doing that. But I am going to have a fairly easier time. Why? Because I see 2 equations and they both have the same variables. So I know this is a simultaneous equation problem. Simultaneous equation problem. And the only way I was able to do that, the only way I was able to notice that is because I first digested the information properly. Okay, now, since I'm trying to find the value of theta, what I can do over here is I can basically I can use either substitution, I can use elimination. I'm going to go ahead and I'm going to use substitution. So I'm going to take my first equation where I have a cosine theta equals 8. I'm going to make a the subject, and so the equation is going to be 8 over cosine theta. And now what I'm going to do is I'm basically, instead of a, I'm going to substitute this into the second equation. So instead of a, I'm going to write 8 over cosine theta times cosine to the power 4 theta is equal to 1 over 8. Okay, so now I can go ahead and cancel this cosine theta out with one of those powers. So there's only going to be 8 cosine 3 theta equals 1 over 8. Now I have this 8 over here. Let's get rid of this. So it's multiplying over here. When I send it to the other side, it's going to divide. So it's going to be cosine 3 theta equals 1 over 8 times another 8 because it's going to divide. So that's going to turn this into cosine 3 theta equals 1 over 64. Okay, now let's try and find out the value of theta. So again, remember, I'm trying to find out the value of theta over here. So what I can do is first let's get rid of this power. If I send it over there to the other side, it's going to be cosine theta equals 1 over cube root 64. Now I don't know what cube root 64 is equal to, so let me just do that. Cube root 64. Oh, it's 4. I remember the cube root is not just going to be on this denominator, but it's going to be on this entire thing. Cube root on this entire fraction. But then see what happens. I can write that in a different way. I could write it like this. Cube root 1, cube root 64. Cube root 1 is just 1, so that's why I didn't write it over here. So this is going to be 1 over 4, and I have to find theta, so I can take the cosine to the other side. It's going to be 1 over 4. And now if I do cosine inverse of 1 over 4, that's basically equal to 1.31811. All of that. I could round this off to theta equals 1.32. They say 3 significant figures, so we have 1, 2, and 3 significant figures over here. Part 2 says, find the exact value of the sum up to infinity. And the way we basically do this is we have this equation s equals a over 1 minus r. So we need the value of a, we need the value of r, and then we can just put that in this formula. Now, we go to the first part. That's going to help us to find the value of a and the value of r. So we know that theta is equal to this value over here. It's also equal to this value over here. And if you read this question statement, they say the exact value. So we cannot give a decimal answer. We have to give the exact answer. No rounding offs, no nothing. So how do we do that? We need 2 things, a and r. So how can we do that? First of all, we can find r. Finding r is way easier because see, r is equal to cosine theta, this thing. And I already know that theta is equal to all of this. And basically, r is equal to cosine theta. Now, I know that theta is equal to this, so instead of writing theta, I can just write cosine inverse 1 by 4. Now, again, why am I not putting in this value in place of theta? this value is the one I rounded off. The question demands for the exact value. So I'm not going to use the rounded off value of theta, I'm going to use the complete value of theta, which is cosine inverse 1 by 4. Now, if you convert it to decimals, it's 1.32 something, 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 but remember, we are not supposed to round off. Exact value means you just give it in the weird form it is, you don't convert it to decimals. So I can solve this over here, r equals cosine, and inside of this cosine, I'm going to have cosine inverse 1 by 4. And see, the magic happens. This is a cosine inverse. They basically cancel each other out. You're left with 1 by 4. If you don't believe me, you can actually check it out. So cosine, and if I close the bracket on this guy, so that's on this guy, boom, it's 1 by 4. So the cosine cancels out with the cosine inverse, which leaves us with 1 by 4. That's the value of r. Now see, if you used the rounded off value of theta, you would not get 1 by 4 this perfectly. Okay, so now we need to find a. Let's find a. How can we find a? Basically, you can use any of these equations. A cosine theta equals 8, or a cosine 4 theta equals 1 over 8. I'm personally going to use the first equation. That one just seems way easier to use. So a cosine theta equals 8. And when I rearranged the equation, I got a equals 8 over cosine theta. Now, what is cosine theta equal to? So remember, r is equal to cosine theta. I just found out the value of r over here. So this is just going to be 8 over 1 by 4. Now, lucky for me, my calculator can do this for me, so I do 8 divided by 1 by 4, which is my previous answer, so I'm just going to put answer in here. That's going to be 32. So a is in fact 32. Now, just realize how everything is connected. R is connected to the previous part. You can find a using this equation, 8 over cosine theta, and cosine theta is r. Everything is sort of interconnected. So keeping your mind open when you're doing, especially your math paper 1 or paper 2, is super important. Everything is correlated to each other. All you need to do is you need to sort of keep an open mind and look for those patterns. Looking for patterns is going to be extremely important in all of these papers. Okay, now we can actually go ahead and use the equation because we have a and we have r right over here. So we use s equals 32 over 1 minus 1 over 4. So let's do that. We got 32 over 1 minus, I could do 1 divided by 4. That's 1 over 4. So I get 128 over 3. Again, remember, no rounding off. You give the answer as it is, so it's just going to be 128 over 3. Okay, so we're on to question number 3, and it's a binomial expansion problem. It says in the expansion of the first bracket raised to the power 5 minus the second bracket raised to the power 4, the coefficient, so we expand these things, we solve them out, we get a term that is x raised to the power 4. They're saying the coefficient of that term is basically 216. So let me just explain to you guys what they're really saying. They're saying you expand this term out, and it could be expanded out to x having a maximum power of 5. And they're basically saying that when you expand this out, you're going to get x to the power 5, x to the power 4, 3, 2, 1. Why? Because this is an x term, this is a maximum power of 5, so that's the maximum number of powers you can have. They're basically saying that there's going to be a term that's going to have x to the power 4. In the same way, you can expand this guy out. This is going to give you a term that is going to have an x term with a power 4. When you equate these two terms from these two brackets, they're going to be equal to 216 x to the power 4. That's what they're saying. Now, we have to find the value of the positive constant p. There's two ways you can do this. You can expand this out fully, all the way to the maximum terms they can give you, and then find out this x to the power 4 term. You can equate them together, and you're going to get something, and then you put it equal to this thing, and then you solve it that way. That's going to be a really long method. Here's what I can tell you guys. So the formula of this binomial basically works something like n choose r, and then you have the a term, which is the first term on the left, and then the b term, which is on the right. And it goes something like a is equal to n minus 1, b is equal to r. So here's how you can, for the first bracket, this is fairly simple. You're trying to find a term that has x to the power 4, right? The way you can do that is you can basically, you need this px term raised to the power 4. That's how you're going to get a term that has x to the power 4. And the way you can really easily do that is you can basically ask the question of how can I get 4 over here in the power? How can I get 4 over here? Sorry, this is not n minus 1, my bad. This is n minus r. Sorry, this is n minus r. So there's this question of how can I get a raised to the power 4? Because what is a? A is basically px, right? You're trying to get px to the power 4. You're trying to raise it to the power 4. The question is, how can I get this a term raised to the power 4? Try and think about this n minus r. What do you do to the n minus r? So n is obviously the maximum possible power that you can have. That's going to be 5. That's not changing. What can r be such that you get a power of 4? So if r is 1, this is basically going to give you a power of 4. What does that mean for us? That basically means this is 5, choose 1. You have 5 minus 1 over here in the power of a, which is basically going to be 4. And then r is 1, so b is just going to be raised to the power 1. And then what is a? A is basically px. And what is b? B is basically 3, so times 3. So what do you get when you expand out all of this? We have our calculator over here. So it's going to be 5, choose 1. That's equal to 5 times 3. That's equal to 15. So it's going to be 15 e to the power 4, x to the power 4. Okay, this is what we're going to get from the first bracket. What about from the second bracket? Second bracket is a bit trickier. For the second bracket, you're going to have, so you're obviously going to have, let me make some room over here. You're going to have n choose r, the a term n minus 1, being multiplied with this b term. And here's what's weird about this. You have an x to the power 3 term in place of a, because that's what your a term is. And then you're multiplying with a b term, but a b term is basically p over x. Basically what I'm trying to say is that this b term and this a term, they are going to cancel each other out. Therefore, you have to choose a power for this guy as well as for this guy, such that their powers are going to, such that whatever the power on this guy is and whatever the power on this guy is, when they end up canceling each other, you have an x to the power 4 term. Make sense? May not make sense right now. So let me just do it, and then it will make sense at the end. So x to the power 3 times, I have an x term over here. They have to cancel each other out. The maximum possible power I can choose, or the n I can choose is, or the n I have is 4. Now, what's going to be my r? What's going to be my value for r? Try and think about it like this. If I raise this to the power 4, or if I raise this to the power, if I raise this to the power 4, and if I choose 0 over here, what does that do? So that's going to turn this entire thing into 1, and then this is going to be 3 times 4, that's 12. Therefore, the choice of r equals 0 doesn't do me any good. Okay, what if I choose a different r? What if I choose my r to be, so what if I choose my r to be, let's say, 3? What does that do? Or what if I choose my r to be, okay, let's try it out with 3 first. So n minus 3 is going to be 1. So x to the power 3, and over here I have x to the power 3. So this cancels out this. I don't even have an x term. So I'm trying to get an x to the power 4 term, correct? So I don't have it anymore. Let's try a different combination. Let's try x to the power 3, and let's try r to be 2. So n minus r, so 4 minus 2 is going to be 2. What does this get me? So I'm going to have a power of 2 over here on this x, and then 2 times 3 is 6. I'm going to get a 6 over here. Now, cancel these two out. What do I get? I get x to the power 4. So that means my r should be equal to what? My r should be equal to 2. That's what I'm looking for. So for this second term right over here, I'm looking for my r term to be equal to 2. Therefore, I have n minus 1. Let me just do it over here. So I have n, which is 4. I'm choosing my r as 2. And then I have my a term, which is x to the power 3. I'm going to raise this to n minus r, 4 minus 2, which is 2. And then p over x. This is going to be raised to the power 2 because r is 2. And so what I'm going to get is, what is 4 choose 2? Let's first do that. 4 choose 2. This is equal to 6. Then I'm going to get x to the power 6 over here. And I'm going to get p to the power 2 over x to the power 2. Cancel these guys out. And I get 6 x to the power 4, p to the power 2. I can write this as 6 p to the power 2 x to the power 4. Okay, so from over here, the term I get is 6p x to the power 4, 6p squared x to the power 4. From over here, I get 15p to the power 4 x to the power 4. And remember, there's a negative sign over here, so this term is going to become negative. So now I have basically this thing, 15p to the power 4 x to the power 4 minus 6p squared x to the power 4. And remember, they tell me that when you subtract these two terms, you equate these two x to the power 4 terms from each bracket, you're going to get this term, 216, which is also going to have, so this all should be equal to 216 x to the power 4. Now here's what I can do. I'm trying to find p. I'm not trying to find x, right? So I can actually get rid of x. I can factor out the x from both of these terms. So I factor out the x from both of these terms. And I have an x on this side and I have an x on this side, so I can basically cancel these two. Or you can basically think about it like this. You take this x to the power 4 to the other side, it divides that x to the power 4, and at the end you have no x to the power 4. So now you just have 15 p to the power 4 minus 6p squared is equal to 216. This in fact is a disguised quadratic equation. It may not look like that right now, but let me bring that 216 to the left-hand side. So this is going to be 15 p to the power 4 minus 6p squared minus 216 equals to 0. What I can do is I can, instead of writing p to the power 2, I can basically write some other variable t over here, and then or y over here perhaps, because that's more familiar. Y and x are more familiar. And then p to the power 4, that what is that going to be? That's just going to be y squared. Okay? And so what I can do is I can basically write 15. Instead of p to the power 4, I'm going to write y squared. And instead of p squared, I'm going to write y. And this now becomes a really familiar quadratic that I could solve using the quadratic formula. So I'm going to go with minus b plus minus under root b squared, which is minus 6 squared, minus 4 times a times c over 2a. Let's solve this out, and let's try and find out what my values for y are. So I have minus times minus 6 is going to be plus 6. Then I have minus 6 squared, which is 36, so I should have written that, but never mind. 4 times 15 times negative 216. And then in the denominator, I have 2 times 15. Let's solve this. One of the values I get is 4. What's the other value I get? So the other value I get is when I put a negative sign over here. Boom, boom. And that is negative. Oh, actually, I don't need a negative sign. So it's negative 18 over 5, but see, here's where it's going to make sense. I'm not trying to find y. Remember, I'm trying to find p. So what I can do is, instead of writing y, I can bring back that y is basically equal to p squared. I can bring back p squared, and I can bring back p squared over here. And you can realize that when I'm going to send the square to the other side, it's going to become a square root over here. When I send the square root to the other side, it's going to give me a really weird answer because it's square root a negative number. Is that possible? No, that isn't possible. You cannot square root a negative number. So in fact, you reject this. You reject this. And you work with this. So you're going to get, what's under root 4? Under root 4 is 2. So you're going to get p equals plus 2 and p equals minus 2. But can you choose negative 2? No, you cannot. Why? Because p is a positive constant. That's what they tell you at the start. So you reject this value as well. So this is your final answer, p equals plus 2. And there we have it. That's question number 3 for you guys. Okay, so now we're on to question number 4, and it asks us to express this quadratic equation that is in its standard form into a quadratic equation that it's in its vertex form. Now this may not look like the vertex form, but that's probably because they have rearranged it, and the way you can basically make it more familiar is you can write the bracket first. Of course, the bracket has a negative sign, and then you have a plus a over here. That looks like a vertex form, and then this right over here is a standard form, but it's not rearranged. So, or it's, I guess, dearranged. So let me rearrange it, and this is going to make it look more like a standard form. So we have to go from the standard form to the vertex form, and there's different ways you can do this. Everybody learns this differently. You can try out your method. I'm going to try out my method. So what's the first step that you have to do? So when you're going from standard to vertex, you want the coefficient of the x squared term to always be a positive 1. Right over here, it's a negative 1, so we just factor out a negative 1 from this entire expression. That's going to leave us with a negative 1 x squared plus 6x minus 1. So now the coefficient of x squared over here is positive 1. That's exactly what we want it to be. Then you take this middle number, just this middle number b, not the sign of it. Now this isn't b, this is 6, but I'm talking about in terms of ax squared plus bx plus c. So you take the middle number b, and you don't take its sign. So it doesn't matter whether it's negative or it's positive. You just take the number, And what you do is you divide it by 2. So you halve the number. That's going to give me 3. Now, in the next step, you're basically going to write everything as it is, but in between the 6x term and the -1 term, or in the b, or in between the bx and the c term, you're going to leave some space. This space is where you're going to use this number. So you add the square of this number and you subtract the square of this number. Now be mindful about one thing. I wrote -3 squared, not -3 squared. These two are different things. One of them is going to turn that negative sign into a positive sign. That's this one. You don't want that to happen, so be mindful about that. Now, in the next step, we're basically going to put two brackets over here, put a square on top of them, and we're going to leave space in the bracket empty and the space to the right of the bracket, my right of the bracket, we're going to leave those spaces empty. What happens in these spaces? So first of all, the first term x is going to come in here. The b term is going to have its sign in here, and then the half term that you were adding, that's going to come over here. So from the x squared term, you take the x. From the b term, you take the positive sign, and then from this adding term, now remember, you're always going to add the square first and then subtract the square. You cannot do it the other way around. So x comes in, the sign from the b term comes in, and then the number next to the positive sign comes in. Then take this part, solve it, and write it down here. So 3 times 3, 3 squared is 9. Multiplied with the negative sign, it's -9. And then -9, -1, that's -10. And then just multiply this negative sign back in here at the end. So you're going to get -x plus 3 squared, +10. And this is your conversion done. If you want it to look like that, you can basically write it as 10 minus x plus 3 squared. And a is going to be 10, and 3 is going to be b. And there you have it. Okay, next part says the graph of y equals x squared is transformed to the graph of y equals 1 minus 6x minus x squared by a reflection, followed by a translation of m and n. Now m would be some translation in the x-axis, n would be some translation in the y-axis. We have to give details about the reflection and find out the values of m and n. This equation, here's what I want you guys to know. Remember when I said keep your brain open? That was really important. If you go back to part A, you're actually going to see that you just converted this thing into its vertex form. Now, they didn't just make you do that for no reason. You're actually going to use it in this B part. So instead of writing y equals 1 minus 6x minus x squared, you can write y equals minus x plus 3 squared plus 10, right? This is the thing we just converted it into. Now we're actually going to use this. This is how you're going to be able to take that y equals x squared and turn it into this new graph or equation that we have over here. So here's how I would recommend you guys to do it. Start off with this initial thing that you have over here, which is y equals x squared. And then what you're going to do is compare it to this newer thing, y equals negative x plus 3 squared plus 10. And instead of, so start off with this thing, and instead of writing y equals x squared, instead write f of x equals x squared. This is just going to help you a little bit. And I'm going to tell you guys in a second why it's going to help you. So try and start with this basic thing and try and convert it into the complex thing. That's how you're basically going to find out what translation and what reflection, and if any other sort of conversion had taken place, what that conversion would have been. So again, what's the strategy? Then you can apply this strategy to any problems. This is a recurring problem. I've seen this in past paper a bunch of times, with different values, of course, but the idea is the same. So you start off with the basic function, and you're trying to convert it into some new, or transform it into some new function. So write the basic one like this, and then try to sort of think about what I can do to it to convert it into the newer version. Okay, so we're trying to convert it to that. So here's what I can do. They see there's some reflection that takes place first, and then it's followed by some translation. Is it a translation in the y-axis, or is it a translation in the x-axis? That's the question. If you notice, in this final answer, remember, we're always trying to compare it with the final answer. The final answer has a negative sign over here, and it has a negative sign with this outside of this x squared bracket. Now try and think about it like this. If I start with this basic thing, and I go ahead and I do this, f of x, and I put a minus over here. What is that going to do to this thing? Is it going to do this? And the answer is, well, yes, that's what it's going to do. It's going to multiply. If I put a negative sign over here, that means I just multiplied whatever I had with a negative sign. If instead I'd have done this, this means something different. This means I've done this. Okay, so whatever I put in this bracket over here is what is going to be the value of x. So instead of x, I would write minus x because I put a minus x over here. But if I put it outside over here, outside of those brackets, that means I take this entire x squared term and I multiply it with a negative sign. Realizing this difference is really important. So I'm not doing the second situation, I'm doing the first situation. I'm putting a negative sign next to my f of x. And that basically puts a negative sign over here. Now, it still doesn't look anything like that. That's because I haven't done the translations yet. But it will look like that once I do the translations. The important thing is, maybe you can identify the reflection right now. Maybe you can't. Either way, it's okay. Thing is, we're close to that right over there. We're just a tiny bit closer. We've done the reflection part. Now, a lot of you may not realize this, and see, the way you do this is you just take a bunch of these problems, you start with this initial position where you have this basic function, you try and work your way to the final answer, you keep on doing that, doing that, doing that until you get enough practice to be able to really do this problem in these kind of problems easily. I have a lot of practice, that's why I can sort of tell what I'm doing over here. But if you don't have any idea, just try and solve the problem and do it that way. So the first thing I do is I do a reflection. They tell me that I'm doing a reflection first. So how do I do a reflection? I take my f of x and I look compared to the final situation. I take my f of x equals x squared. I compare it to the final stuff I have, and I see that my final answer has a negative sign next to that x squared bracket. So what I do is I put a negative sign over here, and that basically means I put a negative sign over here. I don't do it the other way around because that would mean my x squared term is going to have a bracket, is going to have a negative sign inside the bracket. And if you look at this over here, my x doesn't have a negative sign over there inside the bracket. So these are some things that you get from experience. Once you do a bunch of these problems, you start to understand the pattern over here. But basically, I put a negative sign with the f of x, and my x squared term gets a negative sign. So I've done the reflection part. Now, have I done a reflection in the y-axis or the x-axis? So I have done a reflection in the y-axis. So this is a reflection in the x-axis. This is a reflection in the x-axis. How do I know this is a reflection in the x-axis? See, if you do anything inside of these brackets, that is related to the y value. So this is related to the x values, Anything that you do inside the brackets. Anything that you do outside of these brackets means it's related to the y values. Now, I put a negative sign not inside the bracket, but outside the bracket. That means I'm dealing with the y values over here. So putting a negative sign next to f means I'm taking all of my y values and I'm turning them negative. What does that mean? So if I make my grid over here, my y-axis over here and my x-axis over here, let's say I have some graph, or let's say I have a line. I have a graph and it's just a line. Okay, it's a straight line. If I take all of those y values, so this graph is basically y equals 4, right? If I put a negative sign next to the y, that means I put a negative sign over here with the 4. That means all of this graph is now going to be reflected, and it's going to be y equals negative 4. Right? I basically take it from the top part, send it to the bottom part. Same is true for the bottom part. If this graph was in the bottom, I multiply it by the negative, it goes to the positive. Where is this reflection taking place? What mirror are we talking about? What thing is the mirror? This x-axis is the mirror of it. Okay? So when your y values change, your x-axis acts as a mirror. When your x values change, your y-axis acts as a mirror. So since I changed all of my y values, I did something outside of the bracket, meaning I changed something in the y values. That means the reflection is in the x-axis. Now, see how the y and the x are related? Reflection in the x-axis changes your y values. Reflection in the y-axis changes your x values. It's a bit confusing, but you'll get used to it the more problems you do. That's the first thing done. Figured out the reflection part. Now, we have to figure out how do we translate it. So again, see, take the reference point. This right here is the reference point. What does our answer have? So our answer has a +3 and a +10 over here. How do I bring a +3 and a +10 over here? First of all, this +10 is outside of the brackets, so outside of these brackets, right? This +3 is inside of the brackets. So what do I do over here? Basically, I can do this. So if I do x plus 3 over here, what does that mean? That means this thing is, instead of x, it's now going to have, instead of x, it should now have x plus 3. Because I put an x plus 3 in here. So over here I had an x, now I'm going to have an x plus 3. That is the first thing that I have done. Secondly, I have a +10 over here. How do I bring that +10? Now, remember, if I put a +10 in here, that means I'm going to get a +10 in here. I don't want a plus 10 in here. I want a plus 10 outside of this. Therefore, what I do is I basically put a plus 10 over here. And that is going to get me my plus 10 outside of these brackets. These brackets is going to get me over here, plus 10 over here. So now, see how this thing looks exactly the same as that thing? The only problem is I now have to define this translation. Here's another confusing part. If you think this part was confusing, I have another confusing part in this question. It almost appears in all of these past papers that I solve, and it's a recurring problem, and I think I take the most time explaining what's going on over here. I think I'll have to just make a video on this sort of piece of uh, reflection and translation and transformations, and then stop doing this. But so far, this is what I'm explaining. So if you think this first part was difficult, explaining the reflections, wait until you sort of work over here on the translation. If you think the reflection was difficult, wait until you work over the translation. Now, how much did you translate in the x? How much did you translate in the y? So m is the translation that you're doing in the x-axis. N is the translation you're doing in the y-axis. So check this out. M is related to the x values. How much did your x values change? You added a 3 over here. Now you're going to be like, well, that means I moved to the right by 3. Because I have a plus 3 in my equation. I have a plus 3 inside those brackets. In fact, what happens in reality is opposite to what's written in those brackets for the x-axis. So basically what I'm saying is anything that is written within these brackets, in these brackets, for or in other words, for the x values, in reality, the opposite of it happens. Opposite of this happens. So if you see a plus 3, which means you moved every point sort of moved to the right by 3 units, in reality, that means every point in fact moved to the left. If it were written x minus 3, you would think that every point moved to the left by 3 units, but in reality, every point moves to the right by 3 units. Now for the x-axis, it's misleading. This is misleading. You have to keep that in mind. For the y, if you see a plus 10, and that probably means you went up by 10 units, that is the way it is. You move up by 10 units. But for the x-axis, it's misleading. The only case where it's not misleading is where you have a minus next to an x, which means you have done a reflection in the y-axis, and so the values on the right-hand side are now on the left-hand side. You're reflected in the y-axis. That's the only time when whatever is written inside the bracket means actually what you think it means. All of the other times, if you multiply x with 3, in reality, it's not multiplied by a factor of 3, but instead a factor of 1 by 3. Instead, if you multiply it with a factor of 1 by 2, in reality, it's multiplied by a factor of 2. So the opposite of it is happening. Therefore, the translation in y that's taking place is basically every point is moving to the left by 3 units. Why? Because over here it's positive 3. So in reality, it's negative 3. So m is negative 3. Everything moves to the left. For the n value, it's the way it's written. If you see a plus 10, that means you went up by plus 10. And there's no hocus pocus going on over here. You can simply just write plus 10 over here. So that was your reflection as well as your translation. So we're doing question number 5 now, and we're seeing some trigonometry in this problem. So the first thing we have to do is we basically have to do some identity proving. We have to show that tan 4 theta minus 1 is basically equal to some identity that they have given to us in terms of cosine. So how do we go from here to here? Well, you basically take this as your reference point and you just try and keep on applying some identity to this part to turn it into the part on the right side, or vice versa. You can take the right hand side, convert it into the left hand side. But ideally, in most of the problems, you will find it easier, especially in the past papers, in paper 1 past papers, that you start off with the left hand side and try to go to the right hand side. That is the easiest way to do these problems. Two identities that you need to know. So tan theta equals sine theta over cosine theta. And then the other identity you have is cosine squared theta plus sine squared theta equals 1. These are the only two identities you need to know for paper 1. They got the job done, and yeah, that's the start. So first of all, we can see how do we know what to do with our identity on the left hand side. We don't know what the steps are. We don't know how to start. So you don't actually plan this part out. You basically just try and make it look as similar to the right hand side, and you keep on doing that until you get the right answer. That's basically how you do it. So the step is look at your reference point and try and convert. The key idea is look at the reference point and just try to convert what you have on the left hand side to that reference point. So for example, step 1 would be to get rid of that tan because right side doesn't have a tan. So if I have a tan on the left hand side, I try to get rid of that. So I know tan is equal to sine theta over cosine theta, and since that tan had a 4 on top of it, it basically means that if I have a 4 on top of that, I have a 4 on top of these guys, and then I have a 4. I can basically write that as sine 4 theta cosine 4 theta. Remember, there's a -1 over here as well. Okay, looking at the reference point, do I have two different fractions over here? I can sort of put a 1 underneath this one, and now I have two different fractions. If you look at my reference point, does it have two different fractions or just one combined fraction? Well, it has one combined fraction. Therefore, that tells me that I need one combined fraction instead of two different terms. So I can take LCM, turn this into one fraction. So I have cosine 4 theta at the bottom, and over here I'm going to have a sine 4 theta minus cosine 4 theta. Okay, now what can I do next? So you have one fraction, you don't have tan. What else can you get rid of? See, this has a sine 4 theta. Do you see a sine 4 theta in your reference answer? No, there's no sine 4 theta, right? So that's another hint. Try and get rid of your sine 4 theta. So can you see how I'm doing this? It's a feedback loop. I do one thing, then I look at the reference point. Does it have this? Does it have that? I'm basically trying to get as similar as I can to that reference point. That's all you have to do in these identity problems. So I know that there's one equation I can sort of use over here. That's this one right over here. It's the only one I know. And right now it may not be obvious as to how you can use that equation because it's cosine squared plus sine squared theta equals 1. I'm just going to rearrange it a little bit so it makes more sense to you guys. This can be written as sine squared theta equals 1 minus cosine squared theta. So I write it in terms of sine because, see, I'm trying to remove sine. Instead of sine, I need cosines. If you look at my reference point, it doesn't have any sines. It however, does have cosines, and it does have 1. So I can remove my sine theta using this other identity that I know. But the interesting thing is, I don't have a sine squared theta. Over here, I have a sine 4 theta. Now, there are two things that you can do over here. Number one, so this is cosine 4 theta minus cosine 4 theta. You can either write the sine 4 theta as sine squared theta times another sine squared theta, because this is equal to sine 4 theta. And then for each of these sine squared thetas, you can basically use this identity right over here. And instead of writing that sine squared theta, you can write this 1 minus cosine squared theta. You can write that 1 minus cosine squared theta again, and you can multiply them, expand the terms, and that will get your job done. However, I think what's easy is, what's easier to me is I take this equation and I square both sides of the equation. I square the right-hand side and the left-hand side. So what is that going to look like? So if I do that, I'm basically going to get sine to the power 4 theta. So I square this side, and I squared this side. So on the right-hand side, I have 1 minus cosine squared theta, and I'm squaring it. It has a whole square on top of it. This looks something like the identity a minus b whole squared. And I know what that expands out to. That expands out to a squared. So a is 1, 1 squared is just 1, minus 2ab, so that's going to be 2 times a, that's 2 times 1 is 2, times b, so that's going to be 2 cosine squared theta. And then I'm going to have plus b squared, so cosine squared theta, and I square that. So that's going to be cosine 4 theta. So I get this. So I know that sine 4 theta is equal to this entire thing. Therefore, I can go back to my fraction over here. Instead of sine 4 theta, I can write 1 minus 2 cosine squared theta plus cosine 4 theta minus this part now. So minus cosine 4 theta over cosine 4 theta. Check this out. This is plus cosine 4 theta. This is minus cosine 4 theta. This stuff just cancels out. Whoosh. Boom. It's canceled out. I'm left with 1 minus 2 cosine squared theta over cosine to the power of 4 theta. And that is what I was trying to show. So again, just start off, look at your reference point, just try and move your whatever you have, try and convert it to that reference point. That's the best strategy I have for you guys. Part B says, hence, solve the equation this equals 7, and then theta can have values between 0 all the way to 180 degrees. Notice this part. This is the exact part they make you convert to this other stuff. Now, they don't make you do that for nothing. Again, when they make you do something in part A, and then part B has that exact same thing, what you're supposed to do is you're supposed to take that thing that you turned it into and use that thing, not the original one. They're making you do these conversions for a reason. So instead of tan 4 theta minus 1, I'm going to write cosine squared theta. I'm going to write 1 minus 2 cosine squared theta, right? 1 minus 2, yep, cosine squared theta over cosine 4 theta, and that is equal to 7. So now I have to solve this equation and I have to find the value for theta. So let's simplify this equation and see what we get. So over here, the simplifications I can see really obviously are this cosine squared theta can cancel out with this power of 4. So I'm going to be left with 1 minus 2 cosine squared theta over cosine squared theta equals 7. Okay, and then what I can do is I can basically I can get rid of this fraction by sending this cosine to the other side. So I have 1 minus 2 cosine squared theta equals 7 cosine squared theta. And since this term and this term, they're both cosine squared terms, I can gather them on one side. So 1 is equal to 7 cosine squared theta plus 2 cosine squared theta. And now I can add them up so they become 9 cosine squared theta. And I can take the 9 to the other side. So 1 over 9 equals cosine squared theta. And then what I can do is I can basically take this square to the other side. So it's going to be cosine theta equals plus minus. Remember, you take the square to the other side, it's going to be a plus minus 1 over 9. Now, you simplify this, you're going to get cosine theta equals plus 1 over 3, comma minus 1 over 3. So you can basically write this as cosine theta is equal to a positive 1 over 3 and cosine theta equals to a negative 1 over 3. So now all you have to do is you just have to use the trigonometry that you've probably studied to solve out these two situations that we're at. You can do it however you've learned it, however the method is that you know. I'm going to do it using the method I know, and you can copy me, or you can try your own sort of method. Depends on what you want to do. So for the first for this situation, it's really simple. Take the cosine to the other side, so it's going to be cosine inverse 1 over 3. That's going to be, so cosine inverse, and remember, convert to degrees, because this is the problem that has the value of theta in degrees over here. So cosine inverse 1 divided by 3, that is equal to 70.53. I can round it off to 70.53. This is not your angle theta. In fact, this is your angle alpha. This is your angle alpha. And angle alpha is 70.53. Now, why is this your angle alpha? If I get into that, this video is going to be way too long. But the idea is that when you solve it directly, you don't get your angle of cosine directly, but instead you get a basic angle, which is 70.53. If you draw out the grid over here, cosine is positive in 2 quadrants. So in this one, the first one, and in the last one. Why am I talking about the first quadrant? Because this was a positive 1 by 3. This is a negative 1 by 3, so over here I'm going to talk about the negative quadrant. So the basic angle is the angle between, now if you guys don't know what a basic angle is, this is really not the time to be doing yearly past papers, but rather to go to your topicals and to do trigonometry topicals, because you do need to know what a basic angle is. But ideally, it's going to be an angle over here in the positive quadrant, and it's going to be an angle over here in the positive quadrant. This is going to be 70.3, this is going to be 70.3, and then the two angles you're trying to find are this one right over here and this one right over here. Now, lucky for you, you don't need the big angle, you don't need the second angle, you don't need this guy. Why? Because you're only allowed values from 0 degrees to 180 degrees, so you just need that first angle. So that first angle, how much is that? You go from all the way from 0 to that blue line, that's just going to be equal to 70.53 degrees. So over here, your basic angle happens to be your actual angle theta that you're looking for. Now let's talk about it in the case of cosine negative 1 by 3. Again, when you're going to solve this out, you're going to get a value of theta as cosine inverse 1 by 3, and you're gonna neglect the negative sign. Okay, when you're sort of finding the basic angle, you are not going to put in the positive or the negative sign in here. Okay, you're going to neglect that, and the positive and negative signs are going to tell you what quadrant you're talking about, but you're not going to put them in the cosine inverse when you're finding the basic angle. So I'm not going to involve the negative symbol over here. So again, theta is going to be 70.53. And this is not the angle theta, this is the basic angle. And I have to put this basic angle in the negative quadrant. Now, cosine is negative in this sine quadrant, which is this one, and then in this tan quadrant. However, these two quadrants are not allowed to me, this one, this tan one, and this cosine one, so I don't have to worry about them because I'm only going from 0 to 180 degrees. So my basic angle is going to be over here, and this part is going to be 70.53 degrees, but I'm not interested in that part. Instead, I'm interested in this part from all the way from 0 to this blue line. So how much is that going to be? Well, if this part is 70.53 and this part is 180, and how you can find theta is you can basically subtract these two. So it's going to be 180 minus 70.53. That's going to be equal to 109.47. So 109.47 degrees, and these are your two values for the angle theta. So we're on to question number 6, and this is a fairly simple problem. It says functions f and g are defined by f of x equals to an equation that explains f, and then you are given a domain for the function f, and then you are given the function g in the same way you are given a domain for the function g. Now you have to, in part A, state the range of f. So how do you do that? You basically are given the equation for f and you are given the domain for f. So all you have to do is you basically have to find out that for this particular domain, what are the possible values of f you can get? And then those f values are basically going to be the range of f. So let me just do this for you guys. Well, the first thing we have is f of x. I'm now going to write x over here, but this is basically x plus 3 squared minus 12, and the domain for this guy is x can be greater than or equal to 0. Therefore, what that means is I'm going to have for x, I can put a 0 over here, then plus 3 squared minus 12. So what's 3 squared? 3 squared is 9. 9 minus 12, I believe that is going to be 4. So 9 minus 12, that is equal to, actually it's equal to minus 3. So f is equal to minus 3. Now, this is the value you get when x is equal to 0. Now let's see what do we get when x is greater than 0, because see, the domain was x is equal to or greater than 0. So let's say x is equal to 1. What are we going to get over here? So we're going to have 1 plus 3 squared minus 12. And so what is this going to give you? So 1 plus 3 is going to be 4, and 4 squared is going to be 16. 16 minus 12 is going to be 4. 12, 13, 14, 15, 16, yeah, it's going to be 4. And so you're going to get a value of 16 over here. Then see, similarly, if you keep on increasing the values of x over here, so remember it's x greater than 0, right? So you keep on increasing the values of x over here, it's going to add into 3, you're going to get an even bigger number, you're going to square that, you're going to get an even bigger number, and when you minus 12, you're going to have a really big number minus 12. So it's still going to be a really big number. So basically, the range of f is going to be values. So let me just write it over here. F of x is basically greater than and equal to -3. So you get -3 when x is equal to 0, and then as you keep on increasing the values of x, your f of x is also going to keep on increasing. Okay, part B says find an expression for f inverse of x. So we need to find the inverse function equation. What we can do is we basically have f of x equals x plus 3 squared minus 12, and here's what I can do. So the f of x, I make that x, and the x, I turn that into a y. And now what I can basically do is I can rearrange the equation for y. So I'm going to get x, take the minus 12 to the other side, it's going to become plus 12, and I'm going to get y plus 3 squared over here. So take the square to the other side, I believe that is going to be plus minus under root x plus 12, y plus 3. And so you can send the 3 over to the other side, so it's going to be y equals minus 3 plus minus under root x plus 12. And see, now what you can do is instead of writing y, you can write f of x. So that's just going to be f of x. And instead of writing, and you can keep the x the way it is, and you just have to change this y. So instead of writing y, you can write f of x, and it's going to be f of x equals minus 3 plus minus under root x plus 12. Now, here's the idea. Do you choose the positive symbol or do you choose the negative symbol? How do you figure that out? Well, see, they tell you that x is greater than 0. You're actually going to use that piece of information over here. Why? Because the domain of the normal function is equal to the range of the inverse function. Therefore, if the domain of the, oh, my bad, this is an f of x, this is f inverse of x. Sorry, guys. So basically, what I have to figure out is I have to figure out that, hey, if domain of the normal function, so f of x, had a domain of x is greater than or equal to 0, then that means that for the inverse function, the range is going to be greater than or equal to 0. What does that mean? So check this out. So basically, I can only have answers for f inverse of x that are either equal to 0 or that are positive. What does it mean to be greater than 0? It means that you have a positive number. Now see, I have a 3 over here, and this 3 has a negative sign next to it. Therefore, whatever this thing does, whatever this term does, it should cancel out that negative 3. See, what happens if I choose a negative sign over here? What happens if I choose a negative sign over here? If I choose a negative sign, what happens is it's going to be negative 3, negative under root x plus 12. What does that do? So it's negative 3 and another negative number. Let's call it under root x minus 12. Let's say under root x minus 12 solves to give you another number. Let's call that number a. So essentially what you have over here is you have negative 3 and negative a. They're going to add to give you a negative number, right? You don't want a negative number. Your range only allows you to have values that are 0 or positive. Therefore, what if instead I choose a positive sign over here? What does that do? So see, now it's negative 3 positive a. Now this positive a is basically going to try and it's going to try and cancel out this negative part. So basically, here's what I'm going to tell you guys. Basically, if try and think about it like this. Is a positive number, let's say it's a big positive number, and negative 3 is a negative number, right? They're both supposed to, when you have different signs, you're supposed to cancel two things out. Imagine this, you have a big positive number, you have a small negative number. When you sort of do their calculation, is your answer going to be positive or is it going to be negative? Well, your answer is going to be positive, given that the positive number is a big number, and it is going to be a big number. How do I know that? Because, well, see, the range of the original function is going to be the domain of the inverse function. So the domain is basically, the x values are greater than or equal to negative 3. So if you put a negative 3 in here, you're going to get negative 3 plus 12. What is that equal to? Negative 3 plus 12. So that's going to be equal to 9. You under root 9, that's going to give you 3. And if you choose plus 3 over here and you don't choose the minus value, this is basically going to give you 0. And then for all of the x values that you choose that are greater than minus 3, you're going to get bigger and bigger and bigger values, and this answer is going to keep on getting more and more positive. Okay, so basically what we have to do over here is we have to choose the positive sign, not the negative sign. You can easily think about it like this. A negative and a negative will give you more negatives. Okay, so you don't want that to happen. Therefore, you choose a negative and a positive so they can cancel each other out. So the positive answer is what we're going to go with. I'm going to remove the negative, and this is going to be your answer, negative 3 plus under root x plus 12. Okay, moving on to part C. Part C says solve the equation g f of x, which is a composite function, is equal to 69. Man, see, Cambridge always does this. I've seen this number over and over again in different papers. I think Cambridge is not tripping at this point. I think they're intentionally doing this. They're putting this number in Cambridge. I'm watching you guys. This is a kid's paper, so yeah, I'm just going to leave it at that. 6f of x. This is equal to 69. So what I have to do is I have to first find out what 6f of x is. This is basically a composite function. What does that mean? This means that you have an inner function, which is the f of x function. This is the f function, and then you have an outer function, which is the g function. So anything you put into the x, so any input that you put into this composite function, the x value is going to be the input value. It's going to go first into that f function, then the f function is going to spit out an output value, which is going to be f of x, and then that f of x value is going to go into g of x, and then the g of x is going to spit out a g of x value. Basically, that's what's going on over here with the composite function. Okay, so let's try and ask ourselves this. What is the composite function? We don't know what g of x is, so let's try and find g of x. So g of x is equal to 2x minus 5, and instead of g of x, we're trying to find g f of x. Therefore, instead of this x value, we have to put in this function f of x. So it's going to be 2 times x plus 3 squared minus 12 minus 5. That means this is going to be 2 times x plus 3 squared. Then I have 2 times minus 12. 2 times minus 12. That's equal to minus 24. Minus 24 minus 5, that is equal to 29. So this is going to be minus 29. So this right here is going to be my g f of x. Okay, so let me just put it over here. 2x plus 3 whole squared minus 29 equals 69. Let me just see that again, just to check it if that's correct. Yeah, okay. So I have to solve this. That means I have to find out the value of x. Okay, what does solving an equation mean? It means you find the value of the unknown. Over here, x is the unknown. So you send 29 over to the other side. It's going to become plus 29, and so I'm going to have 69 plus 29. That right there is going to be 98. And I can send the 2 to the other side. This is a 3. I can send this 2 to the other side. It's going to be divided by 2. So we can divide this bit by 2, and I get 49. So x plus 3 squared equals 49. Send the square to the other side. So it's going to be plus minus under root 49. Now, you under root 49, you get 7, which means x plus 3 is equal to plus 7, and you get x plus 3 equals minus 7. So this first equation is going to give you the answer 7 minus 3. That's going to be 4 plus 4, and this is going to give you minus 7 minus 3. I believe that's going to be minus 10. Which one of these do we choose? Do we just choose both of these, and that's the answer? How do we figure this out? You go over here to the first part. What is the domain for f of x? It's values that are equal to 0 or values that are positive. Now come back to your final answer. Look at this. What is this? This is a composite function, meaning the x values that you put in here are going to go into the function f. Now, therefore, whatever you put into f needs to be allowed by f, needs to be in the domain of f. So over here, if you have, let's say, x equals negative 14, you cannot put that in the function f of x. Why? Because it's a negative number. The domain of the function f does not allow negative numbers. Therefore, this is a composite function, and the inner function is f of x. So anything that you put into this function must first go into the function f. So it must be of the domain of f. So therefore, this negative number gets rejected, and the answer is simply going to be x equals positive 4. So we're doing question number 7 right now, and this is an arc length problem. It says the diagram shows a sector of a circle with a center O and a radius r. The shaded region is bounded by the chord AB. So what is a chord? A chord is basically a line. You can see A and B are connected by a horizontal line, and the arc AB. So they're saying that the shaded region is basically an arc AB and then a chord AB, and the shaded region is trapped between those two sort of whatever you want to call them, geometries. The size of the angle AOB is 2 by 3 pi radians. So the central angle, that's 2 by 3 pi radians. Part A says, show that the area of the shaded region is approximately 0.614 r squared. How do you show this? So I would recommend you guys to not worry about how you're going to show this. Worry about this part, which says, show the area. That tells you what you have to do. This is going to make itself obvious automatically. So how do you find the area of the shaded region? You can see two geometries. It's an arc and it's a rectangle. If it's a sector and it's a rectangle, if you minus those two things, you're going to get the area of that shaded region. So shaded region, I'm going to call it SR, is equal to the sector area minus the triangle area. Okay, so basically this entire thing, if you minus this area from it, you're going to get the area of the shaded region. Now how do you find the area of the sector? That's really simple. It's basically going to be, the formula for that is, I believe, 1 by 2 r squared theta. Yeah, I think that's the formula. And then for the triangle, you can use a bunch of different formulas. So you can divide this triangle into two pieces. Each one becomes a right angle triangle, and you know the formula for finding the area of a right angle triangle. You can use some trigonometry. If this is 2 by 3 pi, this angle is going to be half of that. Then you can find this side, use 1 by 2 base into height, then multiply it by 2 because there are this triangle and this triangle if you divide it into two pieces, and then add them together, and then you're going to get the area of the triangle. To me personally, that's just a huge amount of working to do, so I'm going to use an alternative formula for the area of the triangle, which is 1 by 2 side A times side B times the angle between them, times the sine of the angle between them. Now side A and side B are basically, you have a central angle, and then you have a side over here, and then you have a side over here. So the sides on both sides of the angle, basically. And over here, if I'm choosing this angle, side A would be this side, and side B would be this side, or that one could be B, this one could be A, totally up to you. But regardless, both of those sides have a magnitude of r. What does that mean in my particular situation? So I can put A to be r, and then I can put B to be r, and then I could put, instead of sine theta, I can write sine 2 by 3 pi. So this is going to be 1 by 2 r squared sine 2 by 3 pi. Let me find out what that is equal to. So let me make sure my calculator is in radian mode. So sine 2 pi by 3, 2 pi by 3. This is equal to under root 3 by 2. So I'm going to get under root 3 r squared over 4. Now, under root 3 r squared over 4, and I have to subtract these two things. So over here, this angle is again 2 by 3 pi radians. So let's do it on the calculator. We have, wait, first of all, this has an r squared, this has an r squared. Let's factor them out. Let's factor those two r squares out. So if I factor both of these out, it's going to be an r squared over here. And now I can solve this on the calculator. Oops, solve this on the... Okay, so we got 1 by 2 times 2 pi divided by 3. Okay, or yeah, 2 pi divided by 3. So this is equal to this, and then minus under root, sorry, that's cube root under root 3 by 4. Yeah, under root 3 by 4. So boom, this is equal to 0.614. And if you look at this part, we need 0.614. So this is 0.614. And then the r squared is outside the bracket. So the area is 0.614 r squared centimeters squared. Okay, so the area I have shown is equal to this thing right over here. Let's move on to part B, which says it is given that the radius of the circle is increasing by a rate of 0.4 centimeters per second. So what does that mean? That basically means that your radius is changing with respect to time. Why? Because there's a second quantity over here. If there was a different quantity, if there was, let's say, centimeter per theta, then that would mean your side or your radius is changing with respect to the angle of the circle. In this case, they're saying that the radius is changing with respect to time. And since this has a positive sign next to it, since it has no sign, it means it has a positive sign. So that means that in every second, the radius of the circle increases by 0.4. So if the radius of the circle at second 1 was, let's say, 0.2, then after 1 second, it would be 0.6. And then in the next second it would be greater, and then so on and so forth. So this is basically my radius, dr by dt, my rate means dr by dt, one quantity is changing with respect to another quantity. This is equal to 0.4 centimeters per second. Okay, this is my dr by dt. Part B says, the first part of part B says, find the rate of increase of the area of the shaded region at the instant when r is equal to 20. Give your answers to two significant figures. How do you approach a problem like this? Here's what you have to do. So they want you, for a second, don't think about this part. For a second, don't think about this part, this R20 part. Think about this. You need to find the rate of increase of the area. What information are you given? So you are given a rate of increase of the radius. Therefore, you somehow have to use that radius quantity to then find the increase of the area. Okay, so you're trying to find the rate of increase of area using the rate of increase of your radius. Now, whenever you're trying to find the rate of one thing using the rate of another thing, you always use something called the chain rule. Now, this is also a recurring problem. I've seen problem that makes you apply the chain rule in multiple past papers of paper 1. So this is going to be a method that you're going to want to learn. We're going to use the chain rule, and we're trying to find what? We're trying to find the rate of change of the area by using the rate of change of the radius. Chain rule is what we have to do. So here's what we're trying to find. We're trying to find dA by dt, right? Here's how you use the chain rule. So first of all, you're going to write the thing that you're trying to find on the left-hand side. Now write these steps down. If you have a notebook next to you, write these steps down. Step number 1. The stuff you're trying to find, the rate you're trying to find, you write it on the left-hand side. Then you put it equal to, and then on the right-hand side, you put the rate that you know. So dr by dt. So step number 1, write the rate you're trying to find on the left-hand side. On the right-hand side, write the rate you already know. Now, what's step number 3? You multiply it with another rate, and this rate has to be, so you have to make this rate in such a way that when you multiply these two fractions, you get that fraction. Okay, so the third rate, you can sort of write it like this: the third rate has to be such that when you multiply it with a rate you already know, you get the rate that you don't know. So what do I mean by that? Look, I'm trying to find dA by dt, right? This doesn't have an r. So if I put a dr over here, what does that mean? That means that this dr and this dr are going to cancel each other out when you multiply the fractions, right? So I put a dr in the denominator over there, and then what do I put over here? Try and think about that. I'm trying to turn this fraction into that fraction. It has a dA in the denominator. So if I put a dA over here, here's what's going to happen. This dr cancels out with that dr, and I'm going to get a dA in my numerator. I'm going to get a dt in my denominator. That's what I'm trying to find. So this is how you apply the chain rule. This is how you do a problem where you are supposed to find one rate using a completely different rate. Okay, so here's what we need to do. We need to find the rate of increase of area. We now have an equation. The equation is basically the rate of change of the radius multiplied by the rate of change of the area with respect to the rate of change of the radius. Now a question may be, how do I find this quantity? How do I find this quantity? Now, I know dr by dt, that's basically given to me in the problem statement. That's 0.4 cm per second. How do I find dA by dr? And this, whenever you do these problems, you're going to run into this thing that you're going to have one of the values directly given to you in the problem, and the other one, you're going to get that from the equation, or the related equation. So you're trying to find an equation that has area as well as radius. And since you're talking about a sector, you're talking about this sector over here. The sector, you are basically trying to find the equation of the sector. So or is it a circle? Hold on. It is given that the radius of the circle. Okay, so it's the radius of the circle. Now, I think that they're talking about the circle then, and not the not the arc. Interesting. Of the shaded region. Oh, okay, so this is going to tell you what related equation you need. So you need to find the rate of increase of the area of the shaded region. Of the shaded region, not of the circle. So again, remember this, you're like, what circle are they talking about? This arc is basically part of a circle. The circle is not fully drawn. They only draw this sector of the circle. Okay, so that's the circle they're talking about. And then that circle has this shaded region inside of its sector. You want to find the increase of this area. So how do you know what this area is equal to? How do you know what the equation for this area is? What's the equation for the area of this? You might say, I don't know. But what did you just find out in step A? The area of the shaded region, that's the equation you found out. So the area over here is equal to 0.614 r squared. That's exactly what you found out. Therefore, what does that mean? You go back to this problem, and what you do is you have this equation. You need to find it. It has the radius r. It's a related equation. Remember, the second part has an a and has an r. So a over here, r over here. This is what a related equation means. It has both the things. So it has the a, it has the r. Now you don't want to find the a or the r. You want to find dA by dr. So you just simply differentiate dA by dr. So it's going to be, how do you differentiate it? You just differentiate it like you would differentiate y equals 0.614 x squared, and you're trying to find dy by dx. That's exactly what you're doing over here. So you're going to multiply 0.614 by 2, 0.614 by 2. That's going to give you 1.228, 1.228, and the power on r is just going to be 1 now. So you get this equation. Now it's going to make sense why they talked about this particular piece of information. At the instant when r is equal to 20, so they're basically saying, instead of r, you can put 20 over here. The radius is at 20. So what they're basically saying is that you initially have this sort of sector, and each second you know that the dr by dt increases. Each second the radius increases with time. So this sector keeps on getting bigger and bigger and bigger, and therefore the shaded region also gets bigger and bigger and bigger. And so what they're asking you is, they're asking you that at one particular time the radius is basically going to be 20, and at that particular instant, that's where we want you to find the rate of change, or the dA by dt of this particular shaded area. So this r, you go ahead and you put it in this equation over here in place of r. Because if you think about it, there's no other place you can put it in, okay? To find dA by dt, you have this 0.4, and you're going to multiply it with this dA by dr. And there's, apart from that dA by dr equation, there's literally no other place where you can put this r value. There is no other r variable. So that's why you only have one equation where you can put that r. So you're going to go and put that r in there. So that's going to be 1.228 times 20. So that's going to be 614, or 24.56. So 24.56. And this is going to give you your dA by dt. So this is going to be times 0.4. Boom. So this is equal to 9.824. This right here is going to be your answer. Now, part number 2 says, find the rate of increase of the length of the arc AB. Give your answer correct to two significant figures. Oh, I think I have to give my answer correct to two significant figures over here as well. So we're only going to keep 9 and 8. I can remove this, and so my answer is going to be 9.8. Okay, so length of arc, again, rate of increase of length of arc AB. Again, what was the information that I was given at the start? I was given the rate of change of the radius. And over here, they're asking me for the rate of change of the arc. Therefore, I'm going to start off with my radius information, and I'm going to find out my arc information. That means I'm going to use the what rule? The chain rule. So I'm trying to find my what? I'm trying to find my arc length. Let's say, so the symbol for arc length, the one I use is S. And so I'm going to go with ds over dt is what I'm trying to find. I write that on the left-hand side, is equal to, what do I know? I know dr by dt. And then I'm going to multiply it with a fraction that at the end, when it solves out, it's going to give me ds by dt. So I want this dr to cancel out with this dr over here, and I can put a ds over here. So this ds, this dt, they're going to get on top of one another, because this dr is going to cancel out this dr, and so my fraction is going to be equal to ds over dt. So that's the idea behind all of this stuff. Sorry, this is a dr, not dt. Okay, so again, related equation for this thing. Do I know that? I don't think so. Of the arc length, yes, I actually do know. So the arc AB basically means this particular arc AB, this guy right over here. And what's the equation for the arc length of a sector? That is basically equal to arc length equals to r times the angle theta. Therefore, that basically means that this is going to be s equals r times theta. Now, I'm not trying, so this is the related equation. I'm not trying to find s. I'm trying to find ds over dr. So I differentiate the right-hand side. It just has an r, so that r is going to disappear. I'm going to be left with a theta. Now, I know the value of theta, right? I know the value of theta. The value of theta is basically 2 by 3 pi. So I can put the value over here as 2 by 3 pi. Okay, and now I know my dr by dt, which is 0.4. I know my ds by dr, which is 2 by 3 pi. So if I multiply these two things together, I'm going to get 2 pi divided by 3. That's that, times 0.4. That's going to be 0.84. I can round it off to 0.84. I have to give the answer to two significance, so I'm going to write ds by dt is equal to 0.84. And that right there is my answer for part B. So we're on to question number 8, and this is my personal favorite topic, integration. Since the diagram shows the curve with the equation y equals 1 by 2 under root x and the point P with coordinates 9, 3 by 2, the shaded region is bounded by the curve and the lines x equals 0, y equals 3. So what does this hocus pocus mean? It basically means that there's this shaded region. It's in between this line y equals 3 by 2, x equals 0, my bad, this line. X equals 0, this line. So x equals 0 is basically the y-axis. And then this curve right over here, which is y equals 1 by 2 under root x. And what we have to do is we have to find how much the area is of this shaded region. There's a bunch of ways you can do this. So there are two ways you can do this. The first way is you find the area underneath this square. Okay, so this guy right over here. And then from that, you basically subtract this area over here. Okay, so if you take that square, subtract this area, you're going to get this shaded region. Something else that you can do is you can basically write this equation. So it's y equals 1 by 2 under root x. You can rearrange this equation for x. So this equation is basically going to be 2y equals under root x, and then you take the square root to the other side. It's going to be x equals, it becomes a square. When you take the square root to the other side, it's going to become 4y squared. What you do is you basically now have this equation. You start to differentiate this from basically. So now basically what I've done is I've turned, I don't know how to explain it, but basically now you're finding this area using the y-axis, not the x-axis. So before we had this square, and the area we were trying to find out was this area, and then we were supposed to minus the two. Now what I've done is I've basically, since I've changed the equation from being in terms of y to being in terms of x, now what we're really trying to, now if we integrate this equation, we're going to get this area directly. But the bounds of integration will also change. So when you were doing it for x, you were going to choose this value from 0 all the way to 9, because we were doing it for x. Now we're going to do it from 0y to 3 by 2y. And that's because we're going to be integrating this thing. Okay, this is in terms of y. So we're going to be integrating on the y-axis, and we are going to be using the y bounds. Now it depends, whatever feels more easy for you, you can go ahead, try and do that. I personally think this is just going to take way less steps to solve. So I'm going to integrate this. So the area of the shaded region is basically going to be the integral of 0 all the way to 3 by 2, which I believe is 1.5, but I'm just going to write 3 by 2 over here. And then this piece over here, 4y squared dy. Why dy? Why not dx? Because again, now I've written things in terms of y, so that means I'm integrating on the y-axis with the y bound, and so I can neglect x. Basically, that's what I mean. 4 being a constant can pop outside of the integral, so I get under root 0 all the way to 3 by 2, and I have y squared dy. Now what I have to do is I have to just integrate it. So what's the integration of y squared? The integration of y squared is just going to be y cubed divided by 3. And then remember, I have the bounds, so 3 by 2 and 0, which I have to apply. So I have a is equal to 4 times 3 by 2 cubed over 3 minus 0 raised to the power 3 by 2. Whoops, this is 3 by 2 divided by 3. All of this is going to go to 0 because numerator has a 0. And then this part is going to be, so this is 3 divided by 2 raised to the power 3 divided by 2. And then in the denominator, I have 3. So I put equal, and I get 0.612. How many significant figures do they want the answer in? They don't say. Do they say the exact value? They don't say. Okay, so I guess I can just write 0.612 as my answer. Okay, now moving on to part B. Oh wait, I just realized the mistake I made in this part. And basically the mistake was that this was not 3 by 2, this was 3. because this over here was 3. So that means this is going to be 3 as well over here. And so I'm going to get, let me just redo this. I'm going to get 3 by 2, 3 divided by 2, raised to the power 3, divided by 3. This is going to be equal to 9 over 8. And then remember, we have a 4 over here, so we're going to multiply that inside the bracket. So if we multiply it, we're going to get 9 by 2. So the answer is going to be 9 by 2. Okay, so we can move on to part B right now. And part B basically says the shaded region is rotated through 360 degrees about the y-axis. Find the exact volume of the solid produced. Exact means no decimal answers. If it's a fraction, you leave it as a fraction. If it has square roots, you leave the square roots. If it has a pi in the answer, you leave the pi as it is. You don't change anything, you just give an exact answer. Okay, so over here, what does it mean for the shaded region to rotate 360 degrees about the y-axis? It basically means it goes about the y-axis like this. And so you somewhat get a shape like this. And this is going to sort of form, I don't know, a weird kind of a shape like this. Now, how do you find the volume of the shape? Now, this is a 3-dimensional shape. It's going to be something like this. I believe it's a trumpet. It looks something like a trumpet. This right over here. This is a 3D shape. How do I find the area of this? Now, you use something that we call the disk method. Now, what's the disk method? So essentially, I have the trumpet over here, right? I slice out a disk from the trumpet. So a really, really, really thin disk. So over here, this is going to be a really, really thin disk. Sort of something like this. Okay, now this is a really thin disk. I'm going to slide this disk out. So this right here is my disk. Now, essentially what I'm doing is there's going to be infinitely many disks. So there's going to be a disk over here, a disk over here, a disk over here, a disk over here, a disk over here. There's going to basically be many, many, many disks over here in this part. Okay, and in infinitely many disks. So as many disks as you can fill up in this particular place. And so what you're really doing is you're adding all of those disks up. You're adding the volume of all of those disks up all the way to this, from all the way down here to all the way up here. So you're basically adding all of those disks up from y equals 0 all the way to y equals 3 by 2. Okay, and so what we have to do is basically when we add all of those volumes up, we're going to have the total volume of the solid that is produced. Now, how do we do that? So essentially what we're really doing is if I can find the formula for one of the disks, I can use integration to add all of these disks. So integration basically means adding. Where am I adding from? I'm adding from 0 all the way to 3 by 2. Okay, from the bottom part to the top part. Now, what is the formula of the volume for one disk? So now this disk has a really small height or really small width, and that is basically dy. Now, why is it dy? Why not dx? Because if you see this disk, I'll chop this disk over here on the y-axis, and so its height is going to be in terms of y, not in terms of x. So therefore, it has a really tiny height of dy. And then what is this area? So what is this area right over here? So basically, this disk it's basically a circular disk, and this radius r is over here. So how do you find the area of a circle? How do you find the area of this top part? It's basically a circle. So to find the area of a circle, you basically use pi r squared, right? And what's this radius? What's this r value? How now you cannot, you have a dy over here. You need this r to be in terms of y as well. Well, what's this r part? We need this r to be in terms of y as well. So check this out. This radius, essentially, this radius, so it starts from this center point. This is where the center of a disk will be, and it goes all the way over here to this part right over here, to this part. Okay, and this part, and then this disk will start over here, and its radius will go all the way over here to this part. So check out, here's what you're doing. You're starting at the y-axis, and you're basically moving some distance to the x-axis. If you start off at the x-axis and you trace a value over here, that's going to be some y value. But right now you're doing the opposite. You're starting at the y-axis, and you're tracing some value all the way to the x-axis. So how do you know what these values are equal to? Each disk will have its own radius, will have its own x values. Lucky for you, you have an equation. You have an equation for the x that I've already made x the subject over here. I have an equation for x values, and the equation is basically 4 times y squared. Therefore, what are these x values? These x values are basically, in other words, these are my radius values. Okay, I start at the y, and I go some value to the boundary of that trumpet, and so that's my radius, and over here the radius is 4y squared. Okay, so what I can do is I can go back down over here. I can say that instead of writing pi r squared, I can write pi times, I know what my radius is, it's 4 pi squared, and I have a square on top of the radius, so I have a radius square over here, and this term, I can simplify this to pi. 4 times 4 is 16, so pi times 16 times y to the power 4. This is what I'm going to get. This is what the area, this part of a disk is. And now I multiply the area times the height. That is what gives me the volume. So what's the height? The height is dy. So basically, it's going to be 16 pi y squared times dy. This is my volume for one disk. And since I'm adding up all of these volumes, what I have over here, the integration basically means to add up all of the volumes from 0 to 3 pi by from 0 to 3 by 2. And what's the equation for one volume? For one volume, it's 16 pi times y squared dy. This is for one volume, and I'm going to add it from 0 to 3 by 2 for all the volumes. So basically, now when I solve this integral, what I'm going to get is I'm going to get the volume of all of those tiny disks, or in other words, the volume of this trumpet. So I have to solve this out: 0 to 3 pi by 2, 16 pi y to the power 4 dy. Let me just check that. Yes, that is correct. Now 16 and pi are constants, so I can bring them outside of the integral, and I have 0, 3 by 2, y to the power 4 dy. What I can do now is I can basically integrate it. So this is going to be 16 pi 0, 3 by 2, and I'm going to have y. Sorry, I'm realizing I can just integrate it on the step. So what's y to the power 4 dy? It's basically going to be y to the power 5 over 5, and then I have the bounds 3 by 2 and 0. Okay, so now we can input the values into these bounds. So we have 16 pi, and instead of y, we can put 3 by 2 to the power 5 over 5 minus 0 to the power 5 over 5. Okay, so all of this is going to be 0, and then let's try and solve out the remainder of this. So 3 divided by 2 raised to the power 5 divided by 5, that's equal to 243 over 160. 243 over 160, and then times 16 pi. So we times this by 16 pi. That's going to be equal to 243 over 10 pi. Now we're going to leave the answer the way it is because they wanted an exact answer. So this right here is in fact the exact answer. Okay, so we're on question number 9 right now, and it says an arithmetic progression has first term 2 and common difference d. The sum of the first n terms is denoted by s of n, which basically means that you have an arithmetic progression which has the first term a equal to 2, and then there's a common difference between the term that is equal to d. And then they say that the sum of the n terms, so it could be the sum of the first 2 terms, first 3 terms, first 5 terms, first 11 terms, that's basically given to you by this s of n. And you could also find this s of n, it has a formula for arithmetic progression. There's a formula for the sum of the first n terms, that's basically equal to n over 2 times 2a plus n minus 1 d. The following line says it is given that s2 minus 1, comma s of 4, comma s of 9 are the first 3 terms of a second arithmetic progression. Find the value of d. Now, this is probably hella complicated as to what we're supposed to do. And let's first ignore this part. Let's first ignore what we have to find. Let's first make sense of all of this information over here. Let's digest this information, figure it out, and then hopefully this d will somehow find itself. This is the strategy I encourage you guys to always do, is to just forget about what you have to find out, but just first take that information and sort of process it. And at the end, hopefully you're going to make something out of it. So there are essentially 2 arithmetic progressions. The first one is given in all of this information, and the second one is given by this information over here. So there's 2 arithmetic progressions. The second one is basically related to the first one. How do I know that? Because see, they say s of n is for the sum of the first n terms in this particular arithmetic progression. Now, this particular line says that this s2 minus 1, so this thing right over here, this s4, this s9, what are these things? These are basically sum of arithmetic progressions, and there's some, and then see this, they come from this part. Okay, the first part that describes what s of n is. S of n is the sum of the first n terms of the first arithmetic progression, and then they use those numbers, those sums, to describe the second arithmetic progression. So basically, there's this particular arithmetic progression, and then you sum it up, and those summed up values describe another arithmetic progression. Okay, so the first arithmetic progression, let me write that over here. First arithmetic, there's no e over there. First arithmetic progression is given to you by, so you have the first term. I'm just going to write term 1. Okay, so t1 for term 1 is equal to a, and then t2 for term 2 is going to be given to you by a plus, it's n minus 1d, but I know since we're talking about term number 2, it's going to be 2 minus 1, n is going to be 2, so 2 minus 1 times d, 2 minus 1 is 1, 1 times d is d, so it's going to be a d over here. And then term 3 is going to be a plus 2d, and then term 4 is going to be a plus 3d, and then so on all the way till you go to term n, and it's going to be a plus n minus 1d. So that's the first arithmetic progression. Now the second one, so the second arithmetic is basically given to you by this particular information. So the first, they say, are the first 3 terms of the arithmetic progression. What are the first 3 terms? This guy, and this guy. So s2 minus 1 is basically the first term of this second arithmetic progression. So this is a. Then we have s4. Okay, so we don't have to put brackets over here. This right over here is s4. s4 is equal to a plus a plus d, and then s9 is basically a plus 2d. So these are all, so see, this was term 1, this was term 2, this was term 3. I'm going to change the variables over here because I don't want us to confuse the variables. So over here, instead of writing capital T1, I'm going to write small t1, so that means it's term 1 of the second arithmetic progression. Over here, I'm going to write small t2, and over at the last part, I'm going to write small t3, so it's the term t3 of the second arithmetic progression. And instead of writing a, I'm going to write capital A over here, capital A, capital A, capital A, and instead of writing D, I'm going to write capital D. So capital D over here, capital D over here. Now, why did I do this? To basically denote this idea that the A terms and the D terms of both these arithmetic progressions are not the same. So the D over here is not the same as this D over here. Now, they could be the same or they could not be the same. I don't know that. Okay, and same goes for this A. So this A and this A, they're not the same. They are different A's. Okay, they could be the same, but I don't know that yet. So what I'm supposed to do is I'm supposed to find the value of D, right? Supposed to find the value of D over here. Now, I don't know how to do that as of now. I don't know how to do that as of now. So I'm just going to sort of leave that. And which D do I have to find? I have to find out this particular D, the small d. Okay, the one that was small d, the one that was defined in the question. This is for the first arithmetic progression. It's in this first statement. The small d is in the first statement. First statement is defining the first arithmetic progression. So the D I'm supposed to find is for the first arithmetic progression. Okay, so how do I find that? As of now, I have no idea how I could find that. Okay, if I knew term number 3 and if I knew term number 2, I could basically subtract them out, and then basically the difference, the common difference would be equal to D. But unfortunately, I don't know term 2, I don't know term 3, or I don't know term 4. So I'm going to ignore that. Here's what I can do. So see, I know that for the second arithmetic progression, maybe, just maybe, I can find out these terms. So this S2 minus 1, S4, S9, what are these? These are sums of the first arithmetic progression. Right? So if I want to find out, let's first find out what S2 is going to be. So let's first find out what S2 is going to be. Then let's find out what S4 is going to be. Then let's find out what S9 is going to be. Okay, so let's find out those terms. And the way we do that is we basically use this idea of S to the power n equals n divided by 2 times 2a plus n minus 1d. So how do I find that? Well, if I want to find S2, I can just say S2 equals, so instead of n, I'm going to put 2. I'm going to have 2 over here. Then 2 times a. I'm going to put in small a over here. And then plus n minus 1d. So n minus 1 is going to be 2 minus 1 is 1. 1 times d is going to be d. So I get this thing. Now, if you realize, they also tell me what a is for the first arithmetic progression. They tell me that a is 2, which means over here I can put 2 in place of a, and 2 times 2 is going to be what? It's going to be 4. 2 times 2 is 4. So 4 over here. Now, let's simplify this. 2 divided by 2 is 1, so I don't have to write that. So I just get 4 plus d over here. 4 plus d. This is what S2 is. Now, let's find out what S4 is going to be. So I'm trying to find S2, S4, and S9. What is S4? So S4 is going to be 4 over 2 times 2 times 2 plus n minus 1. So n is 4, 4 minus 1 is 3, so 3d. And so 2 times 2, this part becomes 4. This part becomes 2 times 1 is 2, 2 times 2 is 4. Then I multiply this 2 over here with this 4 and over here with this 3. So I get 2 times 4 is 8. So I write 8 over here. 8 plus, and 2 times 3 is 6. So 8 plus 6d is going to be my answer. 8 plus 6d. Now, what is S9? Let's try and find that out. So again, I have n, which is 9, so it's going to be 9 over 2 times 2 times 2 is 4, plus 9 minus 1 is 8, so it's going to be 8d over here. Now let's multiply this number inside of the brackets. So over here, this is going to be 2 times 1 is 2, 2 times 2 is 4, and what's 9 times 2? 9 times 2 is 18, and then I have plus 2 times 1 is 2, 2 times 4 is 8. What's 9 times 4? 9 times 4 is 36, so this is going to be 36d. Now these are the values for S2, S4, and S9. Here's what I can do for these values. So I can put so instead of S4, I could put in this value. Instead of S9, I can put in this value. And instead of that S2 minus 1, so I can put in that S2 in there, and then it's S2 minus 1. So what's S2? I've already found S2. If I want to find S2 minus 1, all I have to do is I have to put in the value of S2, which is 4 plus d, and then I have to minus 1 from this. So it's going to be 3 plus d. This is S2 minus 1. So now I know S2 minus 1, I know S4, I know S9. Here's what I can do. Here's how you can find d. This is a bit tricky, but here's how you can find d. So to find d, what I can do is I can create an equation. If I create, basically I need to create an equation that has the variable d inside of it. And if I have that equation, I can solve it out. I can make d the subject and I can get a value for d. How do I find an equation for d? So notice over here, this is term 3, and this is term 2, and then this is term 2 and term 1. So the idea is that the common difference of these two must be equal to the common difference of these two. Basically, that's the idea. Or in other words, what I'm saying is I'm saying the d that so the capital D that you get from this first part is equal to the capital D of that you get from the second part. Or in other words, again, the simple idea is just that if you minus t3, if you have t3 minus t2, the answer that you get must be equal to t2 minus t1. And you're like, well, okay, I get that, but how do I get an equation that has d by just doing this? So here's how you get that. So if you do t3 minus t2, and you say that, hey, this should be equal to t2 minus t1, and what you do is you basically have t3, t2, t2, and t1. You have all of these terms in terms of d. How do I know that? Well, because see, I know that t1 is equal to s2 minus 1. What is s2 minus 1? I just found that out. It's 3 plus d. 3 plus d. And then what's t2? I've also found that out. So t2 is t2 is equal to s4, and s4 is basically this thing, 8 plus 6d. And so t3 is equal to s9. I know what s9 is. It's basically equal to this thing. So what I put in over here is I put t3, that's s9. S9 is basically 18 plus 36d, and then minus t2. So what's t2? T2 is basically s4. What's s4? S4 is 8 plus 6d. Then what is t2 minus t1? So t2 is basically equal to s4. S4 is 8 plus 6d, and then minus t1. So this right here is what t1 is, 3 plus d. T1 is basically equal to s2 minus 1, and s2 minus 1 is basically 3 plus d. So see how we now get an equation that only has the variable d. And therefore, I can solve all of this out for the variable d, and when I do that, I can get an answer for d. So I get 18. If I expand this out, I'm going to get 18 plus 36d minus 8 minus 6d equals 8 plus 6d minus 3 minus d. So I keep on solving this, and I'm going to get 30d plus 10. And from the right-hand side, I'm going to get 8 minus 3, that's 5. 6d minus d, that's going to be 5d. Okay, so get the d terms on one side, get the constant terms on the other side. So 30d minus 5d equals 5 minus 10. This is equal to minus 5. And over here, I'm going to get 25d and make d the subject. So I'm going to get negative 5 divided by 25. So this is going to give me 5 times 1 is 5. 5 times 5 is 25. So negative 1 over 5. This is my value for d. Okay, moving on to part B. Part B says, hence find the difference between the values of the 15th term of the two arithmetic progressions. So basically, you take the first arithmetic progression, and you minus the second arithmetic. And that's how you're going to get, and these are from the first arithmetic term, from the first arithmetic progression, you need the 15th term. And from the second arithmetic progression, you need the 15th term. So from both the arithmetic progressions, you take out the 15th term and then you subtract them, then you will have their difference. That's what difference means, is you subtract both of those terms. Now for the first term, you can actually go ahead and find the 15th term. So the 15th, t15th, is basically going to be a, which is 2. Now again, I'm talking about the first one right now. So t15 is going to be 2 plus n minus 1, n is 15. 15 minus 1 is 14 times d. I just found out that d is minus 1 over 5. So we can solve this out on the calculator. So this is 2 plus 14 times minus 1 divided by 5. This is equal to negative 4 over 5. So negative 4 over 5. This is from the first arithmetic progression. Now let's find it for the second one. But you're going to realize for the second one, it's not going to be that easy. If you try and find t15, it's going to be equal to a plus 14 capital D. Do we know a? Maybe. So we do actually know a. So the first term is, this a term is basically equal to s2 minus 1. And we know that s2 minus 1 is 3 plus d. Since we know the value of d, we can actually solve 3 plus d out. D is minus 1 over 5. So this is equal to 3 minus 1 over 5. This is equal to 14 over 5. 14 over 5. This is the value for a, capital A. Now what's the value for d? Let's find that out. So we can use this equation. So what is s4? S4 is basically 8 plus 6d. So s4 over here is 8 plus 6d. So I can solve that out. 8 plus 6 times d d is negative 1 over 5. This is equal to 34 over 5. 34 over 5, and this is equal to S4 is the second term. So S4 is right over here, the second term. So it's a plus d. A is 14 over 5, 14 over 5 plus d, and I can solve for big D. So 34 over 5 minus, I have 14 over 5. Now this is equal to 4, so d, capital D is equal to 4. Now what I can do is I can basically put in the value of a over here, which is 14 over 5 plus 14 times d. D I just found out is 4. So I have 14 over 5 plus 14, 14 times 4. 14, give me a second, 14 times 4. So this is equal to 58.8 or 294 over 5. I'm just going to write 58.8. This is 58.8. Okay, now what we can basically do is we can subtract out both of these terms, so negative 4 over 5, negative 58.8. And so this is going to be times minus 1. So I have negative 58.8, negative 4 over 5. And this is going to be 59.6. So negative 59.6. That is basically the difference between the 15th terms of the first arithmetic progression and the second arithmetic progression. Now, if you want, you can also remove this negative symbol over here. Why? Because it already says, hence find the difference. So the difference basically means is how much gap there is between two things when you subtract, or how much less one thing is compared to another. So you can basically, since the word difference already accounts for the negative symbol, you can also write difference is equal to 59.6. Okay, so now we're on question number 10. It's a circle problem. It says that a circle has the equation x squared plus y squared plus 4y minus 21 equals 0, and a straight line has an equation 2x plus y minus 8 equals 0. The line intersects the circle at 2 points. Find the coordinates of these 2 points of intersection. So basically you have a circle. This equation is for a circle. So I want you guys to think about the circle, not the equation. So this thing over here, all of this equation, it's a circle. All of this stuff over here, this is a line. Now we don't care about what kind of line it is. I mean, you can find out if you sort of do some rearranging over here. So if you write this in the form y equals mx plus c, that's going to be minus 2x plus 8. So I know that due to this negative 2, it's a downward sloping line. So it's going to be like this. It's going to be downward sloping, and it has a y-intercept at positive 8. So yeah, it's going to be somewhat like that. And therefore, this line is going to cut a circle like this. So if I have a circle, let's say this line cuts a circle like this. So it could cut it over here at this point. It could cut it over here at, no, not at this point, because they say there are 2 points of intersection. So this line cannot be a tangent line, but this line could cut it over here. This line could also pass from the center point and cut it over here. Now, a common misconception is some people might assume that the line when it cuts these 2 points, this guy and this guy at the top, and then this guy and this guy over here, that this length is going to be the diameter of the circle. Well, no, it's not going to be the diameter. It's going to be the chord. The diameter is basically, it's a length that passes through the center point. So if your line doesn't pass through the center, it's not the diameter. So just be careful about that. Anyways, that was just some side information. What we have to do is we have to find those 2 points of intersection. So the easy way to do this is to use the method of substitution. So you start off with the equation of the line, which I basically have over here. I turn it into the y equals mx plus c form, and just take this equation and substitute it into this circle equation. So you're going to get a merged equation, and that merged equation basically gives you the points of intersection. So I have x squared plus y squared. So y is minus 2x plus 8 squared plus 4y, which is minus 2x plus 8, and then minus 21 equals 0. Okay, let's try and solve this now. So I have x squared plus, and then what's minus 2x plus 8 squared? So this is just going to be a, so if I rewrite this, I can rewrite this like this. This is 8 minus 2x. And so 8 minus 2x is basically the same as a minus b whole squared. So it's going to be a squared is 64, 8 squared is 64, minus 2ab, so 2 times 2 times 8, that's going to be 32, 32x, and then plus b squared. So b squared is going to be 2 times 2 is 4, and x squared. And over here, I'm going to get this 4 multiplied over here and over here, so it's going to be minus 8x plus 4 times 8. 4 times 8 is 32, and then minus 21 over here. Now let's open these brackets to simplify these things a little bit. So I have x squared plus 64 minus 32x plus 4x squared minus 8x plus 32 minus 21 equals 0. So what's plus 32 minus 21? that's basically going to give you 11, positive 11. So you're going to get positive 11 from over here. And then here's another constant term. So you add 64 into that 11, that's 75. So this is 75. And then let's see over here, we have this term, this x term, and this x term. So minus 32 minus 8 is going to be minus 40x, minus 40x. And then I have an x squared term over here, x squared term over here, so it's going to be 5x squared. And now I have a quadratic equation. So I have a quadratic equation, which I can, if I solve, I'm going to get two x coordinates of the points where the line intersects the circle. I can simplify this quadratic equation if I want to, but I'm just going to leave it like this, and I'm going to use the quadratic formula. So I'm going to use minus b, so minus b, which is minus 40, plus minus under root b squared minus 40 squared minus 4 times a, which is 5, times c, which is 75, over 2a, 2 times 5. Okay, so let's solve this out. I have minus 40 is going to be plus 40 plus under root b squared minus 40 squared minus 4 times a times c divided by 2a. So 2 times 5 is 10. This is equal to 5. So 1 point is 5. And the other one is basically going to be equal to, put a negative sign over here, that's going to be equal to 3. So these are the 2 points where the line intersects the, what do you call it, the circle. And then what I can also sort of have over here is if I put the y, if I can find the y coordinates, so I can take these points, put them in either this equation or this equation and find out the y values. I'm going to use the line equation because that's just more simple. So the line equation is y equals minus 2x plus 8. Y equals minus 2x plus 8, yep. So we're going to put in 5 into this equation, so it's going to be y equals minus 2 times 5 plus 8, and then I have y equals minus 2 times 3 plus 8. So negative 2 times 5 is negative 10. Negative 10 plus 8 is negative 2. So the first coordinate is 5 comma negative 2, and then the second coordinate is negative 2 times 3, that's negative 6 plus 8. Y equals negative 6 plus 8 is positive 2. So the other coordinate is 3 comma positive 2. So these are the 2 coordinates I have. So these are the 2 points of intersection. Okay, let's move on to part B. Part B says, do we have a part C? I don't think so. Okay, no part C. Okay, part B says the circle has a center C, and the 2 points of intersection are denoted by A and B. So A could be the first point, B could be the second point. We just found out that it's one of those points we can say is 3 and 2. 3 comma 2, and then point B is 5 comma negative 2. So I just selected points A and B based off of which one is more to the left side and which one is more to the right side. Since this guy has x as 3, it's going to be to the left side, so I'm calling it A, and then this side has x on point 5, so it's going to be to the right side, that's going to be B. So we have to find the area of the triangle ABC. Now let me just tell you guys what ABC is. So there's some center of the circle, right? I'm just going to assume a drawing over here, a rough sketch. So let's say this is the point right over here. Let's say this right here is the center point, and then we have one point, so this is C, and then we have one intersection point at 3 positive 2, so let's say 3 positive 2 somewhere over here, and then we have 5 negative 2, so let's say 5 negative 2 is somewhere over here. Okay, and then what you can do, so this is a rough sketch, I don't know if it actually looks like this or not. So what we have over here is this is the line going through points A and B, and they're basically asking for this triangle over here. This triangle over here. Now here's the strategy. Here's how you can do it. If you know the radius, so if you know radius r, so these 2 points are the radius. Why? Because they go from the center to the circumference of the circle. So if you know the radius r, and if you know the length of this chord, which AB, which you can easily find out using your distance formula, then what you can do is you basically have a triangle like this, and you can sort of split it into 2 equal parts. So this distance that you're going to find, this is going to be d by 2, this is going to be r. You can apply the area formula on this part, 1 by 2 base times height. What's going to be the height? The height's going to be this part, this h. You can find that out using the Pythagorean theorem, because you're going to know this side and this side, and then you can basically multiply it by 2 because there's this triangle and this triangle. So that's my plan right now. Okay, one question could be, how do I know that this line doesn't pass through the center? Right, because if it doesn't matter if it doesn't matter if the points A and B are let's say over here. Let's say over here. So let's say this is A, let's say this is B. That still doesn't matter because at the end of the day, I'm going to get a triangle. I can still use the same strategy. Find the radii, then find this distance, and everything works out the same. So it doesn't matter if A and B are on this side of the circle or on this side of the circle. Also, how do I know that it doesn't, the line doesn't pass through the center? So how do I know that it's not this particular situation? Well, because see, if the line passed through the center, then my point A would be over here, point C would be over here, point B would be over here. There would be no triangle ABC. So that's how I know that it's not passing through point C, because in order for a triangle to exist, it must not pass through point C. Now the question is, how do we find the radius of this circle? So we can do that by looking at the equation. So I can go back to the equation over here, and the equation is x squared plus 4 squared. So I'm going to write that down: x squared plus 4, wait, x squared plus y squared here, right? X squared plus y squared, so x squared plus y squared plus 4y minus 21, plus 4y minus 21 equals 0. Okay, so it's this thing right over here. How do we find out the radius? Well, basically, you need to take this form to the standard form, and then basically from that standard form, you will be able to tell what the radius is, and you will be able to tell what the center point is, the center coordinates are. So how do we do that? We basically, first of all, we take this constant to the other side, so it's going to be x squared plus y squared plus 4y equals 21, and then we basically complete the square. So we complete the square for this x, and we complete the square for this y. So x squared doesn't have an x term, so I'm just going to write 0x over here, and y squared does have a term, so it's plus y squared plus 4y equals 21. So it does have this 4y term. Now, how do we complete the square? We look at this 0 term and we look at this 4y term, and we divide both of these terms by 2. So 0 divided by 2 is simply 0, and 4 divided by 2 is going to be 2. So I have x squared plus 0x, and that 0 I just found out, I'm going to add that 0 squared and subtract that 0 squared, and then I'm going to do the same for y. So subtract the 0 squared, add the 0 squared, and then y plus 4y plus add the 2 you just found out, add the square of that 2, subtract the square of that 2, and then equals to 21. So what next? So basically put 2 brackets over here, put a square on top of them. This x comes in here, this positive sign comes in here, that from the plus square term, the 0 comes over here. Okay, then what's next? Do the same for the y part. So you got y over here, this is y, the plus sign over here, and then from this plus square term, you take that 2 over here. Now you have 21. What about this minus 0 squared, and what about this minus 2 squared? You basically take them to the other side of the equation. So taking 0 means nothing, but taking minus 2 squared basically means you're taking this basically means that this is going to be 2 squared is 4, so this is minus 4. You're taking minus 4 to the other side, it's going to become plus 4. So what you have is x plus 0 squared plus y plus 2 squared equals 25, equals 25. So how do you find your radius? Basically, this term over here, this equation is now in its standard form, and therefore the term over here represents r squared. Okay, once you get it in its standard form, the constant term over here represents r squared. So if you want to find r, you just under root the 25, and that's going to be 5. That's the value of your radius. That means that the radius is equal to 5. The radius is equal to 5. How much is this diameter? So to find this, or sorry, not this diameter, how much is this distance, or this chord length? To find this chord length, I have points A and B, and I can find the distance between them. So the distance between them is going to be under root the coordinates of B minus the coordinates of A, and I have to square them. So first of all, the change in x squared, and then plus the change in y squared. So I have D equals under root, what is change in x? I'm going to go 5 minus 3 squared, right? So 5 is for point B, 3 is for point A, and then add the square of the change in y, which is minus 2, minus 2, minus 2. Minus 2, minus 2, yes. So this right here is a plus 2, but when I do minus 2 minus a plus 2, it's just going to be minus 2, minus 2. Okay, so now what I have over here is basically 5 minus 3, that's basically 2 squared, plus minus 2, that's minus 4 squared. Okay, so if I solve this out, I'm going to get 2 squared is 4, plus minus 4 times minus 4 is 16. So I have under root 4 plus 16. That is equal to 2 under root 5. I really hate that I got an answer like this, but sure, I'm going to keep it. 2 under root 5. Now, I'm not going to round this off because this is not my final answer, and I don't want to lose accuracy over here. So I'm going to keep it in this form. So this part, basically, if I draw out the triangle, this length is r, which is 5. This entire length was d, which was 2 under root 5. And so this length right here would basically be d divided by 2. So d is this. If I divide this by 2, I'm just going to get under root 5. And I have to find this height. And I could basically do that using the Pythagorean theorem. So the hypotenuse squared, the radius is the hypotenuse. So I say the hypotenuse squared, 5 squared, is equal to the sum of the squared of the other two sides. Sum of the squares of the other two sides. Okay, so 5 squared is 25. I have h squared, and then I have plus 5 under root 5 times under root 5. What's that going to be? That's going to be 5. So you take it to the other side, take the 5 to the other side, becomes minus 5. And now 25 minus 5 is 20 equals h squared. Take the square to the other side, it's going to become a square root. So your answer h is basically under root 20. Now, I'm not going to round this off to decimals because I'm trying to keep the accuracy. And so what I can do is I can basically apply the area formula right now. Which is basically, so you can do two things. You can either use the area formula on this full triangle, so basically on this, let me change colors over here, so on this full triangle. So for that full triangle, it's going to be area is equal to 1 by 2 times the base, and so it's going to be this big base, 2 under root 5 times the height, which we just found out is under root 20. Or what you can do is you can basically find it for the smaller triangle, this guy, which is going to be a equals 1 by 2 times the base, which is under root 5, times the height, which is under root 20. And then you can multiply this answer by 2, by 2, because there are two such triangles. Now I'm going to go with a bigger triangle, so I'm going to have 1 by 2 times 2 under root 5 times 20 times 20. So this 2 cancels out this 2, which leaves me with under root 5. So I have under root 5 times under root 20. That is equal to 10. So that is 10, and my area is going to be equal to 10. Okay, guys, we're finally on the last question of this paper, question 11. It says a curve passes through the point P equals 4, x4, and y3, and is such that, so they give you two pieces of information over here. They tell you that a curve passes through this particular point and that it has this equation for its gradient or its derivative. So I don't think there's anything to digest over here, so we can simply go to the part A of the question, which is find the equation of the normal to the curve at P. Give your answer in the form y equals mx plus c. So there's two things that you need to find the equation of them. So normal is going to be a line. Let me just tell you what they're asking for. Let's say this is the curve right over here. Let's say this point is 4, 3, the point P. So there's of course going to be a tangent line at this point. So a tangent line over here. And let's say what they're asking for is the normal line. So the normal line is a line that makes an angle of 180 degrees to the tangent line. And so to find the equation of any line, you need two things. You need point and a slope. Now, lucky for you, you already know the point because this point is normal to this tangent line. They both pass through this point P. So the point can simply be 4, 3. What about the slope? Well, lucky for you, you have the derivative equation. Therefore, you can find the slope of this tangent line at point P. And therefore, what you can do is you can basically inverse them. So you can basically take its negative reciprocal. The relationship between the slope of a line and its normal is that the slope is the negative reciprocal of that slope. So if, for example, a line has a slope of 2, then its normal line is going to have the slope of its negative. So it's negative, and turn that into a negative, and then a reciprocal. So a reciprocal of 2 is going to be 1 by 2. Similarly, if it was let's say negative 11, then it's reciprocal, or negative 4 by 3, then it would be positive and it's reciprocal, so 3 by 4. So that's the idea. That's how we're going to find the slope. That's how we're going to find the point. And then we're going to use the equation y minus y1 equals mx minus x1. So the point slope form to solve this out. So the idea is first find the slope, because that's the only thing we need to find. The point has already been given to us, and then using this equation, find the equation and then turn it into this form. Therefore, first thing we have to do is find the slope. So we have the equation for the slope dy by dx is equal to 8 over x squared. So we're going to leave the space for x. And then over here, it's 10 over 2 times x, leave the space for x again, minus 3 squared. What is x? X is the x coordinate of point P, because we're trying to find the slope of the tangent line at point P. So x is equal to 4. Put a 4 in here, put a 4 in here, solve this out. So it's going to be 8 over 4 squared is 16. And then minus, you have 10 over here. So 2 times 4 is 8. 8 minus 3 is 5. So it's going to be 5 squared. I'm realizing I could have just written 25, but anyway. So this dy by dx is equal to 1 over 10. Let me just check that again. 1 over 10, perfect. Now we have the point, we have the slope. Let's start off with this form. So y minus y1. What's y1? Y1 is going to be equal to the coordinate. So we have 4, 3. So this is y1, this is x1. So y1 is 3. And then the slope is going to be, again, remember, we're trying to find the slope for the normal. So now the slope is going to be the negative reciprocal of this slope we just found. This is the slope of the tangent line. The normal line is going to have a slope of negative and reciprocal. So the reciprocal of 1 over 10 is just 10. So it's going to be negative 10 and then x minus x1. So x minus x1, which is 4. So we got y minus 3 equals minus 10x and then plus 40. Now we have to rearrange it to give the answer in the form y equals mx plus c. So it's going to be y equals negative 10x. Take this 3 to the other side, it's going to add. 40 plus 3 is going to be 43. So it's going to be this thing right over here. Y equals negative 10x plus 43. That's your answer right there. Part B says, find the rate of change of the gradient of the curve when x is equal to 4. Now, this is a tricky question. So you want to find the rate of change of the gradient. Okay, this over here is the rate equation for the rate of change of the curve. What is the rate of change of the curve called? It has a special name. It's called the gradient. But then what is the rate of change of the gradient? So if you have y and you dy by dx it, and you or rather if you have y and you apply the rate of change on it, it becomes dy by dx. So similarly, if you have dy by dx and you apply d by dx to it, what does this become? What does it become now? And it becomes, so d times d is going to be d squared y over dx times dx is going to be dx squared. Does this look something similar? This is the double derivative. It's the double derivative. So this, what they basically said, is a fancy way of saying find the double derivative. The rate of change of the gradient is what we call the double derivative, and the rate of change of the curve is what we call the gradient. So just some terms you need to know. Okay, so we need to differentiate this again, and okay, sure, we'll do that. So what's dy by dx? dy by dx is equal to 8 times x minus 2 plus 10 times minus 2, and inside of the bracket I believe we have 2x plus 3 or 2x minus 3. Let me just check that. 2x minus 3. So 2x minus 3. 2x minus 3. Okay, so let's differentiate it again to get the double derivative. So this is going to be negative 2 times 8 is 16, x minus 3, and then I'm going to have 10 times negative 2, that's going to be negative 20, and then this is going to be 2x minus 3 times, raised to the power negative 3, and then times, I'm going to multiply this with the differentiation of this bracket. That's how you differentiate when you have a bracket. So the differentiation of the bracket 2x minus 3 is going to go to 0, and then 2x is just going to give me 2, so I'm going to multiply this by 2. So this is going to be, the double derivative is going to be d squared y over dx squared is going to be, and I have to find the double derivative at which position. I have to find it when x is equal to 4. So what I can do is I can basically put a 4 over here, and I can put a 4 over here in place of x, and so I'm going to get negative 16 times 4 raised to the power negative 3, and then I have minus, so this 20 times that 2 is going to give me negative 40, so negative 40 times 2 times 4, 2 times 4, minus 3 raised to the power negative 3. So I press equal, this is equal to negative 57 over 100. Negative 57 over 100. Oh wait, I realized I made a tiny mistake over here, and the mistake was basically, this was a positive that I copied, but if I go back, it was a negative over here. So if I times this negative over here by this negative 2, it's going to become positive over here, not a negative. And therefore, when you solve it, you're not going to get, when you put in 4 over here and you put in 4 over here, you're not going to get negative 57 over 100, but you're going to get positive 7 over 100. So it's going to be positive 7 over 100. Okay, so now we have part C. Part C says, given that the curve also passes through the point negative 1 comma q, find the value of q. So how do we find the value of q? Here's how you can find the value of q. If you have the original equation y equals something 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 in terms of x, what you can basically do is see x, what is q? Q is the y value, and x is negative 1. So you can basically put into this equation, you can basically put in x equals negative 1, and you're going to find that value of q. That value of q is basically what you're trying to find out. So how do you get this equation? That's the question. So you can get this equation by basically using this gradient equation. If you integrate this, you're basically going to get the curve equation. And then using that curve equation, you can find out your point q. So if I integrate all of this, so all of this, I have 8x minus 2, 8x minus 2, plus I then have 10, wait, was this, okay, so it's a negative sign, it's not a positive sign. See, I was going to make that mistake again. So this is a negative sign, and then I have 10, 2x minus 3 raised to the power negative 2 dx. So I have to integrate the gradient. Let me just check if I copied everything correctly. 2x minus 3 squared x over 8 over x squared. Yeah, I think I copied everything correctly. Okay, so I have to integrate all of this. So when I integrate this first part, I can basically separate both of these bits and pieces. So I can separate them to this part, and then minus the integral of 10 2x minus 3 minus 2 dx. So I can separate them into these two pieces. This 8 can pop outside the integral because it's a constant. So can this 10 because it's a constant term. And so over here, I just have to integrate x minus 2. So that's going to be equal to x minus 1 over minus 1. And then for the next part, to solve this, I can apply u substitution, and I can call this part as my u, and therefore I need to find out what du by dx is. So differentiate this thing with respect to dx. I'm going to be left with 2. Now make du the subject, so du is going to be equal to 2 times x. 2 times dx. Or something else that you can do is you can make dx the subject. So if you make dx the subject, that's going to be equal to du over 2. Okay, so you know that dx is equals to du over 2 and that u is equal to this piece. So over here, you can now, instead of writing the bracket, instead of writing this bracket, you can write u. And so there, u is going to have a power of negative 2. And then instead of dx, you can write this thing because you just found out what dx is equal to. So dx is equal to du over 2. And now you can basically take this negative 2 outside of, not this negative 2, but this divided by 2 outside of the integral because it's a constant. So I can simplify this part into negative 8x raised to the power negative 1. And over here, I'm going to get negative 10 divided by 2 integral u minus 2 du. So if I integrate this, first of all, this is going to be 5. So I get negative 8 over x, negative 5 times u minus 2. So what's the integration of this? It's going to be u minus 1 over minus 1. And I can simplify this to basically get a positive 5. Instead of u, I can write that same thing back over here. So that's u was basically equal to 2x minus 3. We can write 2x minus 3 over here. And this is minus 1, so I can simplify this further. Plus 5 over 2x minus 3. And remember, there's going to be a plus c at the end because this was an indefinite integral. So all of this is now what my equation of the curve is, y equals to all of this. I have to find out point q. So for that, I know that my x is negative 1. I can chug that into this equation, but the problem is I have this plus c. So I need to find out what this plus c is. The way you can do that is you can use the point p, which the curve passes through. And point p has coordinates 4, 3, 4, 3, 4, 3. So you put these points in here. For y, you're going to put in 3. And then for x, you're going to put in 4. And then over here for x, you're also going to put in 4. And then you're going to find out what your plus c is equal to. So let's simplify these fractions a little bit. Negative 8 over 4. And then I have plus 5 over 2 times 4 is 8. 8 minus 3 is 5. So I can simply just write 5 over here. So this is going to be negative 1. So it's 3 equals negative 1 plus c. Now we rearrange this equation so it becomes 3 plus 1. So c is equal to 4. So my equation is negative 8 over x plus 5 over 2x minus 3 plus 4. And now I can basically put in x equals negative 1 in here, this guy, negative 1, and I can find out what q is going to be. We can put in the value of x in here, so x minus 1 over here, and then 2 times minus 1 minus 3 over here. This is minus 3, and plus 4. We can use our calculators to solve all of this. So we got negative 8 divided by negative 1, and then we got positive 5 over 2 times negative 1, negative 3, positive 4. And all of this is equal to 11. So y is equal to 11. Therefore, that means q is basically going to be 11.